Hi, Sarah.
Hi.
Sorry I'm late for the forum.
No problem. Is everything okay?
Oh, yeah, everything's fine. Everything's fine. I was just picking up some solar cells that I ordered for my home.
Solar cells, what are they? Are they a kind of food?
Not exactly. Solar cells are like a tablet kind of thing, and you put it on top of your home, and it basically turns sunlight into electricity for you.
Okay, I didn't know it's calling like this. So in my home, I just use regular electricity, and it's worked just fine. Why do you bother yourself using solar cells?
Well, solar cells kind of make electricity for free, and I don't really like to pay my electricity bill. But they're also like better for the environment, and as part of Vision 2030, moving towards renewable energy sources like solar power is a better move than just staying with whatever regular sources we have, which could be more polluting.
Okay, so nice. It's a smart decision, though. So you use the sun to power your home.
Mm-hmm.
Nice. So is that what they call it, sustainability?
Yeah, definitely, for sure. It's definitely a part of sustainability. And it's funny that you should mention that, because that's actually what we're here to introduce in this forum today.
Okay, so let's leave the audience enjoying the forum.
Yeah, enjoy the forum. But actually, right before we start, I think we want to introduce, we have the Vice President here. So if the Vice President would like to grace us with her presence on the stage. Dr. Hiba Al-Khashim is a professor of mathematics and the Vice President of Prince Sultan University.
Bismillah ar-Rahman ar-Rahim. Respected Dean, College of Humanities, Professor Mahmoud Al-Mahmoud, honorable invited speakers from KAXT, KFUPM, Al-Faisal University, and University of Edinburgh, PSU Higher Management, respected deans, vice deans, chairs, associate chairs, faculty members, and our distinguished students. Bismillah, assalamu alaikum wa rahmatullahi wa barakatuh, and a very good morning to you all. It's my great pleasure to welcome you all to the second Science Research Forum organized by the Department of Mathematics and Sciences under the umbrella of the College of Humanities and Sciences here at Prince Sultan University. I'm Hiba Khushaim, the Vice President for Women Campus, and I'm honored to deliver the opening remarks on behalf of PSU President Dr. Ahmed Al-Yamani, who is not able to join us today. First of all, I would like to seize this opportunity to congratulate and commend the effort made by the organizers of this academic and professional meeting that discusses a vital topic, that is sustainability in research. This forum symbolizes a kind of collaborative effort that we are seeking for a sustainable future here at Prince Sultan University and within the Kingdom of Saudi Arabia. We expect this scientific event to shed light on research, specifically on the recent advancements in science and technology related to sustainability, a theme of high priority here at Prince Sultan University in recent years. The forum aims to connect regional researchers and practitioners to pioneer scientist network and discuss sustainability's efforts, challenges, and advancements. The goal is to track, share, and showcase the latest research in sustainability and the SDGs. In fact, this event is one of the many efforts at Prince Sultan University for the advancement of research. In this regard, PSU has established 22 research labs and groups that cover a broad range of research activities that are in line with regional, national, and global strategies, and that aim to support PSU's effort for a sustainable future. Besides, PSU established the Center for Sustainability and Climate this year to transform commitments into action and build a decarbonized world, driving technological and economic transformations to realize sustainable competitive advantage. Sustainability covers many aspects, from economy to society, and from education to research. On the other hand, research has been and continues to be the driving force for economic growth and advance and development in all aspects globally. This can be seen in the amount of research funding that is invested by countries, and specifically here in the Kingdom of Saudi Arabia. And of course, we have CAC's representative here to confirm that. Additionally, sustainable research is the backbone of Sustainable Development Goals, known as the SDGs and the KSU Vision 2030, since the allocated funding targets strategic fields, such as health, SDG 3, water desalination and treatment, SDG 6, energy like and green hydrogen, SDG 7, and environmental protection, SDGs 13, 14, and 15. In this regard, PSU is also investing in R&D, thanks to the Research, of course, and Initiative Center at Prince Sultan University. More importantly, PSU strongly supports research through the recruitment of postdoc, funding projects from 30,000 and up to 300,000 Saudi riyals, and so on. Indeed, PSU has recently launched a new lab, Energy, Water, and Environment, under the College of Humanities and Sciences in 2022. Now that we know what to expect in the coming few hours, let me close by giving my gratitude to those who are behind such an event. First, on behalf of PSU, I would like to thank all distinguished speakers and guests who joined us today. I also would like to acknowledge and thank the organizers of the forum, all committees participating, and logistics departments who devoted intensive hard work, time, and efforts so we can all benefit from today's event. My gratitude goes, of course, to the College of Humanities and Sciences, Dean, Vice Dean, Chairs, and Associate Chairs for their support. Finally, I wish you all a fruitful and enjoyable forum, good networking, and potential future collaborations between all participants. Let me stop here and let the excitement begin. Wassalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Dr. Hiba, for the wonderful speech. I'm sure the Dean of the college would also like to say a few words. So if you'll join me, everyone, please welcome the Professor of Linguistics and Translation and the Dean of the College of Humanities and Sciences, Professor Mahmoud Al-Mahmoud.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله وبركاته. It is my honor to welcome you to the second Science Research Forum organized jointly by the Department of Math and Science, the Theoretical and Applied Sciences Lab, and the Energy, Water, and Environment Lab. The importance of this forum comes from the fact that research has emerged in recent years as a top priority in higher education. To this end, and for the College of Humanities and Sciences, keeping in line with the PSU's research strategies is essential through extending external collaboration with other and local and international institutions. The second round of the Science Research Forum is devoted this year to sustainable research. Eminent speakers representing a wide spectrum of academic and research institutions have been invited to share their respective institutions' research visions and strategies during today's upcoming discussion. In addition, the forum will host several speakers from the mathematics, chemistry, physics disciplines who will present their research findings. It is the college's intent that this forum will provide a platform in exchanging ideas, information, and experience among academics and research scholars in the field. I hope that this forum provides a common ground where new challenges facing research in the field, shared by most of the academics who are present here today, are put on the table. I would like to thank all the guests who have accepted the invitation to share with us their success stories. In particular, many thanks go to the Department of Math and Science as well as the organizing committee for their efforts in the preparation for this forum. Finally, the college extends its gratitude to higher management of PSU. Without the ongoing support of the PSU's president, Dr. Ahmed Yamani, who is not unfortunately able to be with us today, Dr. Hiba Hushaim, the vice president for the female campus, who graced us today with her presence, this event would not have been possible. Finally, and in closing, I wish you all an enjoyable day filled with fruitful discussions leading to potential future collaboration. Assalamu alaikum.
Thank you, Dr. Mahmoud, for an inspiring speech. Usually you will speak inspiring. And now I'm excited to start the forum for the first session. What about you, Muhammad?
Yeah, so am I. I think with that, it's time to welcome to the stage Professor Kamaluddin Aboudia to chair the first session of the forum. Please welcome Professor Kamal.
Assalamu alaikum. It really gives me a great pleasure to welcome you here in our second science forum. We wish all the guys here more successful, inshallah. Our first guest speaker here is Dr. Wafa Saleh from Edinburgh University. She's a professor of transport engineering. At the moment, she is a guest professor in Princess Noura University. She has, mashallah, more than 150 papers. Sorry, I have to look what you are doing. Thanks a lot. Please, Dr. Wafa.
Thank you. Thank you, Mr. Chairman. Good morning, and welcome to this session, my paper. First, I would like to thank the organizers of this forum. Thank you for the invite. I'm delighted to come to the forum. I'm delighted to come to Prince Sultan University. It's my first visit. I am very impressed by what I've seen so far. I'm delighted to actually be able to witness the era and what's happening in the kingdom with all its ups and downs, but I can see the trend is going up. You're a lucky country that you've got the resources and the various components needed to make a progress and to make a difference and significant differences. And I see that you are on the right track. You're doing a good job. You're doing an excellent job indeed, and I'm sure in a few years we will see the kingdom move to another ranking altogether. I think, as the introducer said, that sustainability is a multi-faceted thing, is a multi-faceted issue, which needs a lot of effort and components and resources. But one of the very important aspects of these is the behavior and the mentality and the ability to progress and change. And you've got the new era, you've got the Vision 2030, which sets actually very good routes and opportunities for the change and for the progress. And I could see, and I've seen this morning actually, lots of changes in the behavior and the mentality. That's why I'm saying that I'm sure in a few years' time we will see a big difference in this country. So my presentation today on sustainable engineering in the energy sector relevant applications to the case. Just about myself, I'm a civil engineer, graduated from Newcastle University in the UK, and I've done a PhD in modeling transportations. My main focus of the research as an engineer, I came across many aspects of engineering, including modeling travel behavior, transport and the environment, safety, etc., and many others. Currently, also, I'm a visiting professor at PNU University, which gave me a few very good opportunities to do something and to contribute, I hope, positively to the development of the first National College of Engineering in Riyadh, at least. I should be safe to say that. So I will present at the end of this one of the projects I've been involved in. So I don't think I need to talk about Saudi Arabia, probably that was for myself, the driving forces, opportunities and challenges. About Saudi energy resources, I'll say very briefly something Saudi plans for future energy and sources of energy in the country. Challenges, and I'll talk about the green hydrogen at PNU because this is a project I witnessed and contributed to, and they've done quite a good amount of work there, and final remarks. So I think I will, I ask the chairperson, please, if you could give me 5 minutes signal before I finish, so not to talk for 2 hours. Case is, Saudi is a big country with lots of resources, and it's got very significant characteristics of the population and the behavior and the resources of energy, of course. There are lots of work on renewable energy and the Vision 2030, and as such, sustainability and sustainable engineering policies in the energy sector are a priority. The sustainability stems from the behavior of the people. The people, whether they are students or teachers or politicians or decision makers or government, etc. So I think we need the integration of all of them. This is just, I think, a map for myself to show the size and the location of the country and the opportunities come with that. So the Kingdom of Saudi Arabia is the largest consumer of fossil fuels in the Middle East, as it meets of its energy needs from oil and gas. You produce gas and oil a lot, and you use them a lot. So even though you're producing them, if you don't use them that much, there will be an opportunity cost. You sell them, and then you use more renewable energies, which you've got also, a lot of that. The energy needs of the country are expected to rapidly grow with the current policies and the rapid developments in the country and population, economy. So there will be an increase in the demand of the energy. The Kingdom of Saudi Arabia has unique characteristics. I've always been interested in the Kingdom of Saudi Arabia before I came to visit, as very specific characteristics in the culture and behavior and resources and all of that. So I think all of them needs to be considered when we look at the energy and sustainability. So it's clean, domestic and renewable energy is commonly accepted as the key future life globally and in the kingdom. The industrialization going on at the moment initiated long-term plans to replace current energy sources with renewable and sustainable energy. And the kingdom is very keen to match with that attitude. So in that context, we have 3 challenges: increasing the energy production from natural resources, reducing the overall energy consumption, and protecting and improving the environment while enhancing the socio-economic development. So there are 3 axes or 3 different challenges, but we need to be looking at them in an integration manner. The kingdom is facing several challenges in this context. The kingdom has to adopt new long-term energy strategies to reduce the share of fossil fuels, which is ongoing. The main objective in the sector is to meet the increasing demand for energy in line with economic development, targets, population growth, etc. Lots of international justification as global warming, pollution reduction, lots of emphasis and requirements and targets set for the kingdom to, including national, to achieve in the sustainability area. Also, the kingdom would like to be perceived and seen and working actively to be at the forefront in terms of the technology, sustainability, and the economy. So we've got these challenges: a vibrant society, thriving economy, and ambitious nation. Main sources of power in the KSA is not only petrol and gas. There is the sun, there is the wind, there is hydraulics, there is many actually natural resources which dictate itself for the country to look at renewable energy sources and adopt them. However, at the moment, 99.5% of the total electricity generated and used in the kingdom is from the fossil fuel, from the petrol and the gas. So the country's power generation is highly still dependent on hydrocarbons, which are present in a lot in the country. The petrol in Saudi Arabia is quite a lot. It's cheaper than water, I found. It's cheaper to buy petrol than to buy a bottled water. And it's fantastic. But as we said, there are pressures to change this attitude and look at the opportunity costs and start on sustainability. If we look at the main sources of power at the moment in the kingdom, the oil is the blue one, the gas is the gray one, and the renewable is probably, I don't know whether you can see that orange line, but that hopefully is changing. The good news is recently electricity generation from natural gas and a reduction in power generation from crude oil has increased. In 2019, electricity generation from oil was 149.6 terawatt hours, and from the gas, 206. So there is a significant improvement and significant interest in that direction. This is due to the country's global movement shifting to cleaner energy sources of energy. The kingdom is not an exporter of gas due to its use in electricity generation. So any saving in gas or oil could be exported, and that would contribute to the more positive and the healthier economy. Saudi Arabia, setting this as a priority for gas production for domestic use in power generation market. This is just to show the total reserves in millions of oil equivalent barrels, and the, if I can point to this, the Saudi Arabia is the gray one. Where do I? Yeah, well, the blue grayish petroleum color there. So that is very good. Current development of renewable energy sectors in the kingdom. The kingdom has launched its Natural Renewable Energy Program in 2017. Which is a strategic initiative under the Vision 2030. The program aims to maximize the potential of renewable energy, and in 2020, the country launched the third round of NREP, the National Renewable Energy Program, round 3 of that, which was comprised of 4 solar PV projects with a combined generation capacity of 1,200 megawatts. I've got lots of data and information about this. So if you need any further details of these, which I put some here, but I don't want to go through all of them, but I have them. So I've done lots of research on that. You could request them if you're doing a project or want more information on that. So there is a healthy rise in renewable energy sector and the total energy generated from renewable energy. This is to reduce oil and gas usage in power generation and use it for more export of hydrocarbons from the country, thus lowering its CO2 emissions. Renewable energy installed capacities in megawatts. So this is just to show, even though the amount is not a lot, it just shows the progression and the increase in the renewable energy in the country. Again, this is the global direct primary energy consumption. So we're not alone. You are not alone. It is a global thing. So we are in the race. But we've got more resources. We've got more opportunity actually to win the race because we've got the right components in this country. We've got the right ingredients to win the race. So let's try. Development of renewable energy sector in the kingdom. The KSA government has developed an energy policy aimed at diversifying energy sources and suppliers and attracting private sector, which is very important. Special attention in the government energy policy is renewable and nuclear power generation. Renewable energy resources include biomass, hydraulics, solar, wind, geothermal, wave, tidal, biogas, and ocean thermal energy. And all of these actually potentially available in the kingdom. So while we have more emphasis on the solar energy, for example, or wind energy, we can work on any of these, or you could work the students, universities, research institutions, etc. We can look at all of these and select what's most appropriate to the kingdom. What happens at the moment is every organization or company or country come to offer their experience in terms of the sustainability and energy sector, whether it's wind or solar. But no one actually knows yet what is best, which of these is the best in terms of renewable energy, in terms of sustainability, the long-term impact, and all of that. That all needs research, and it has to be set in the agenda of the national research, university research, etc. So the sharp growth of energy sector has been also witnessed by institutional reforms, and that we all seeing. Energy policy and view of the future. So what I'm saying here is just planning energy research and development activities to meet the requirements, diversifying energy supplies and avoiding dependence on a single source of one of them. Solid and liquid, sewage, composite, waste, biogases, all of them are candidates. Implementing measures for energy efficiency, preventing waste and minimizing losses in the energy production. That's also very important. Protecting the environment and public health in the process of meeting energy requirements. So, as I said, we don't want to concentrate only on solar energy, and we don't even know what are outside the boundaries we have. We can produce energy from solar, but then what are the impacts of those? I'm not saying that it's not good or good, but we need to take the whole process and know the consequences of them. Few examples of renewable energy sources: wind power. I'm not going to talk about those because I'm sure I am progressing in my time. Wind power, I personally think, is a very powerful source of energy and would be very successful in the kingdom. Needs to be investigated. So I've got some information here about wind power and, sorry about this. In the kingdom, there are some efforts here and some energy generated using wind power. Renewable energy from solar energy. Solar energy is actually one of the biggest source of renewable energy in the world in terms of the interest in it and the work being done in it. And the Kingdom of Saudi Arabia is into this. And we at the PNU University, and I will show you what we've done, also generating some energy from solar sources. So you've got a lot of sun, obviously, so that is a good source for you. Like wind power, PV markets have seen rapid growth and thus costs have fallen dramatically. I would say again this, although there is a lot of interest and growth in solar energy, we don't know all the consequences of them yet. That needs research. So solar energy in the KSA, there is a lot of projects and a lot of growth in the amount of energy produced by that. I'm not going to go through all of them, but I've got all these figures. If anyone needing them, I could provide them, no problem. So that's one. Biomass energy, that's also another source, and there are some projects in the kingdom on that, but not a lot, but there are experimentations. So any of these projects, actually, there is a database. We can get this database and do more investigations to understand what's going on and what is potentially best for the country. Nuclear power, one of the sources of energy on the agenda, and the hydrogen. And there are many colors of the hydrogen. I'll only talk about the green hydrogen because the green hydrogen is obviously the optimum. And because we are at PNU, where I am a visiting professor there, we've done some work to produce green hydrogen from solar energy. So this is one of the cleaner ways of getting hydrogen. And I'll skip that because I'm sure there are other speakers who will talk about hydrogen. Dr. Rasha, I knew that. We've got a number of projects at PNU on green hydrogen ongoing. But one of our projects, which I'm very keen on presenting, and I like too much because I was sort of leading this, the first CPV, concentrated PV cells in Riyadh, I hope, I believe. First, KSA University to produce green hydrogen from solar energy. That's PNU. You're all invited to come and see this. A research project on green hydrogen, the main aim was to fuel vehicles for mobility, and partly funded by MISC, and was in collaboration with Tokyo University. So we built a green hydrogen facility. There are some issues to be sorted, like storaging, transporting, compressing, fueling, but I think also Dr. Rasha is going to talk about that. So I'll skip this, and I'll go to some photos to show you our green hydrogen lab, which we produce currently a maximum of 34 kilowatt hour. Then this could be converted to hydrogen using power converters to produce just under 1 kilogram of hydrogen. 1 kilogram of hydrogen would drive a vehicle for 100 kilometers. So that is significant and very impressive. So this is where we set the foundation for our facility. And that was hard, but very interesting and exciting work. There, that's me. I put this picture in my presentation to prove, but I thoroughly enjoyed that opportunity. Never had this opportunity in the UK to build a hydrogen lab. So we had the foundation, then we put the mast, we had a huge crane and assembled the PV cells outside, then moved them into the mast with the collaboration of a Japanese team. It was a brilliant experience. This is CPV cells, which actually is supposed to be much more efficient in producing electricity than the ordinary PV cells. But yet, that's something to be proved. We have to do research in this to prove whether these are more efficient or not, because The catalog, the manual says it's more efficient. It's more efficient for Saudi Arabia because this is better for the high temperatures. The normal PVs are less efficient in very high temperatures. But again, we bought this facility, not necessarily bought it, but we bought the facility as we buy any goods. But we don't know whether the manual tells us what is real. So that's why we need research. We need research and opportunities in every facility we have. We've got data. I attended a conference recently on the national disasters. And you as a kingdom, as a country, contribute hugely in that. I think the minister paid, I can't remember, $40 million or something dollars contribution to that, which is great. But I said to them, where is the data? Why don't you get the data from these projects to study and to understand what's going on? Then we can derive policies to prevent these in the future. This is our CPV, and this is the first time, and they give me the manual operation of it, and they saw it moving after I've been working with them in the field for a long time. This is our team, Dr. Arish, the Dean of the College of Engineering. I'll point to her because I always say, what a crazy dean, so she lets us do whatever we want to do, and the Japanese team. It's a project we're very proud of. Although it produces something very not significant in the overall global picture, but it is a step forward. It's good for the students to see the facility and come and play with it and see the hydrogen using a small electrolyzer in the control room, get the hydrogen, blow a balloon with PNU University, and understand beyond the textbook and what's, because anyone can teach this. They can look at the online material and study. But these sort of facilities, I think it widen their perspective and knowledge and opportunities and future opportunities. So this is actually currently, it looks a little bit better because they paved all of that and put flowers and stuff. But this is our fantastic CPV unit. We've got sensors, wind sensors, and weather sensors, so we can collect all this data and investigate the impact of dust, impact of temperature, impact of wind, all of that. So with that, I think I will, do I have any? 1 minute? No. I think I'll stop with that, and if any questions relevant to the next, I think what we need, just to conclude, we need integration of efforts. We need to work outside the box. We need, you have lots of opportunities and resources, and I think it is in safe hands, and you're doing a great job. And I will be delighted to see in 5 years' time what's the overall picture in this country. Thank you very much, and thank you.
Just wait. Thank you, Professor Wafa. Any question? Yes.
Thank you very much. My name is Muhammad Humayun, and I'm working as a researcher at Energy, Water and Environment Lab, PSU. I just joined this lab, and my research direction is hydrogen production and carbon dioxide conversion. Actually, you talk about the green hydrogen production on kg scale, right? So what kind of material you use in these PV cell?
CPV, they concentrate.
And is there any effect of temperature?
Well, as I said, we've just installed the system. We've got now, we're collecting all the, we can, like, we have monitors, we have sensors for the temperature, the wind, the weather, the rain, the temperature of the cells, and that is what we're just starting to collect and look at for students and for researchers as well, to actually looking for a researcher in this area, to start seeing what are the impacts of this on the energy generated. But I mean, I can give you more details of that, maybe just outside this. Yeah.
Thank you very much.
Thank you, Professor Wafa. So you are now at the first stage to test the PVs only for energy production. So we didn't start, electricity production. So we didn't start already the water splitting or electrolysis to produce hydrogen yet. Am I right?
We do have a very small electrolyzer which is set in. So we're producing hydrogen to blow a balloon. But the second stage is to build the fueling station.
Yes.
So we will have a small size fueling station and a hydrogen vehicle. So we will have an industrial size electrolyzer to be able to generate enough hydrogen to do something significant.
But the most challenging for hydrogen production is the catalyst.
It is.
You know.
Yeah.
So are you doing research on catalyst or just you buy again catalyst at this stage?
No, we will fuel vehicles hydrogen, but we need to sort out. We've still got lots
optimization
to do.
Of the process.
Yeah, we're talking with the Ministry of Energy. Now the facility is up and running, and we're generating electricity, which is actually powering the gate here and the control room with the air conditioning and everything. So now we are in a good position to negotiate and find out how we're going to do the second stage. We have Toyota on board, but we're still negotiating with them hardly. So we want to get the most we can get from them. So we'll see.
Toyota is about fuel cells, you mean? Or?
Sorry?
Toyota for fuel cells?
Yeah.
Okay. Thank you.
So they weren't
because I worked with Toyota on fuel cells when I was in Japan.
But they weren't included in this.
Yeah.
This is we've done at PNU, just us. But we're hoping, because they will provide the hydrogen vehicles.
Yeah, I know. Yeah.
So it is overall a project, like a very practical
very
project.
Very encouraging project, of course.
At a university for the students and the staff and the research. Yeah.
I fully agree with you. Thank you so much.
Thank you very much. Thank you very much.
Thank you again, Professor Wafa, and we wish you all the best in your project. Our next talk will be given with one of our colleagues, Dr. Rasha Abu Musa, who is a professor in physics, and she is one of the active researchers in the EWE lab. She will talk about hydrogen technology towards net zero emission. Please.
السلام عليكم ورحمة الله وبركاته. يعطيكم العافية جميعا. First of all, I would like to thank everyone here that would listen to me. I have to introduce myself. I'm Rasha Abu Musa. I'm a PhD holder and assistant professor in the Mathematics and Sciences department, and also I'm a senior researcher in the EWE lab. I have been delegated by my professor Mohammed Boudina to produce this talk about the hydrogen production or hydrogen technologies in general towards net zero emission. In this research, in this presentation, we are talking about the energy sources and renewable energy sources, the hydrogen energy and types, how it will be produced, how the hydrogen is stored, and the application of the hydrogen. And we will talk about the challenges that we face in the hydrogen economics. Finally, we will talk about the semiconductors as a photocatalytic technology for the green hydrogen production. I am a scientist, but I know that not all of the audience are scientists, so I will talk in a brief way that I will make it easy to all to understand what is the basic difference between the renewable and the non-renewable resources. For the renewable resources, from their name, they are sustainable resources that they are abundant and they are easy to use. At the end, they are clean and they will result as a zero pollution. Some of these renewable energies is the biomass, the hydropower, the geothermal power, wind power, and the solar energy. For the non-renewable resources or energy, this is the one that we are usually using every single day, like the petroleum, natural gas, coal, and uranium. But unfortunately, they are limited resources. They are causing pollution and they making a global warming. So all of the renewable energies, all types, I will explain in brief how they are works and how they generate electricity. In the first one, to the top to left, it is the biomass materials. Those are biomass materials. They are inorganic materials like charcoal or wood. They are using them, burning them to make the cooking, heating, and lighting. But they have some cons that they still have some hydrogen, some carbon dioxide emission. But still, this carbon dioxide emission is still limited compared, or lower range compared with the other non-renewable resources. In the hydropower energy, we are using the water resources such as the oceans, the waterfalls, and they are directed to turbines and electropowers. They are generating electricity, and then they are directed to supply the homes and businesses and industry. At the bottom, to the left, this is the geothermal energy. This type of geothermal energy, they could be let's say, categorized to different types according to the temperature, depending on the crust of the Earth's surfaces. At the bottom, they could be as a dry steam, they could be wet steam, and they could be in a high temperature water. In the case of wind power, as Dr. Wafa, she said, it's an interesting kind of power, but unfortunately still it have limitation because some of the countries and some of the lands, they don't have a wind. So we cannot use the turbines to generate electricity by using wind power. That's why there is no, let's say in general, there is no difference in the temperature on the land. So this will cause that no air will keep to move and there is no wind will be generated. According to this, I cannot use this power in any or all countries. Finally, we have this solar cell. It is an interesting and promising type of renewable resources. We have a different type of solar cells. They are directly absorbing the photons from the solar energy, and then they start to produce electricity that we can use them in different usage. What about the hydrogen as a sustainable source of renewable energy? Hydrogen, it's all of us, we listen and hear nowadays hydrogen everywhere, hydrogen, hydrogen. But do we know what is hydrogen and how we can use the hydrogen, how the hydrogen works? I think before like 1 year, me also, I wasn't know about the hydrogen. I was just listening hydrogen, 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 but I don't know in details what is the hydrogen. So the hydrogen is a material, it's a gas actually, and this gas it could burn like any material, and it will generate a very high energy compared to any other energy resource compared with the fossil fuel. As Dr. Wafa also said, she said that 1 kilogram of hydrogen could produce that in a vehicle could move 1,000 kilometers, which means this is a huge amount of energy has been released from the hydrogen. The hydrogen, it has a mass-specific heat energy content among like 119.9 megajoule per kilogram compared with other fossil and the gasoline and the petroleum. It has only like 44.5 megajoule per kilogram. The most important thing in the hydrogen, it is a clean source of energy. It is a healthy kind of energy. It calls for us for a long term, not for us actually, maybe for our kids, maybe for our for their future. They could live in a life that there is no warm global. We need to reduce it a little bit to ensure that they could maintain their life with no problems. Usually also we listen that green hydrogen. Do anyone know what is the green cause, or what do we mean by the green hydrogen? Why I didn't say, let's say, pink hydrogen? Why I didn't say brown hydrogen, blue hydrogen, gray hydrogen? Actually, to be honest with you, all of the colors that I mentioned, it's there. The pink, brown, blue, gray, and the most important one is the green one. Now, what is the basic difference in between of them? The gray and the brown hydrogen, they are coming because of burning the fossil fuel, and they are, unfortunately, they have a high carbon emission. So they are not the target that we need. We need a zero carbon emission at the end. So that's why the researchers, they start to look for a new type of hydrogen, how they can produce the hydrogen, and then they start to add some modifications on their research, and they found that there is a new type of hydrogen, which is the blue one. This is a cleaner type of hydrogen. The cleaner type because of, we are not emitting the carbon dioxide. No, the carbon dioxide is there. But the best thing is that we can capture this carbon dioxide and we can reuse it again. So we are avoiding that in carbon dioxide which could harm our global. Finally, and the cleanest one is the green hydrogen. This green hydrogen has been used by renewable energies, electricity, and as a result, there is a zero carbon emission. That's why it is called as the clean hydrogen. I hope that it's a little bit clear for you the difference between the colors and why we use the hydrogen. Now, how we can product or the production of the hydrogen? As I said at the beginning, do you see to the right? Here is the hydrogen production, all of the colors that I mentioned. We're starting with the brown, then there is the gray, the blue one, a little pinkish one, and then we end with the green one. It's the cleanest one. طبعا the starting was by using the fossil energy. During some of the process, there are the steam reformation, the cracking, and the gasification. They will produce the brown and then the gray one. After that, they modified a little bit by still they use the fossil fuel, but they make some of the carbon sequestration. This will produce the pinkish one. In the case of the green one, we use the electricity from the renewable energy, and through the process of the electrolysis, we are splitting the water here, and we produce the green hydrogen. The energies that we use it, as you see there, it's the top left, they are the biomass, the direct solar PO, the hydro, the wind. They are the renewable resources that we talked about them a while ago. What about the hydrogen storage? Actually, it's an obstacle about the research related to the hydrogen, how we could store the hydrogen. Because we will talk a little bit later about the challenges that the researcher found it about the hydrogen. But hydrogen in general could be stored in a different way. It could be stored by a physical basis, if it's either compressed gas or even called compressed, or even could be stored as a liquid hydrogen. And it should be done within a specific conditions. In the pressurized one, or the compressed gas, it should be stored at a room temperature from 200 to 700 bar, which is a huge amount of atmospheric, it's a huge amount of the pressure. In the case of liquid hydrogen, the condition, it should be stored at minus 253 degrees Celsius from 1 to 5 bar, but still it's a very low temperature. In the case of the other type of how to store the hydrogen, we use it in the material type. It could be absorbent, liquid organic, interstitial hybrid, complex hydride, and chemical hydrogen. There is some of the listed example material has been used to use it as a material paste to store the hydrogen, but still in this case we need a room temperature, but 10 bar to 50 bar as a pressure to store it. The application of the hydrogen. I put a two picture because actually I cannot limit the usage of the hydrogen energy because we can use it in everything. As simple as that. We can use it in industry, we can use it in home, we can use it in businesses, we can use it to generate a new type of, regenerate hydrogen again back, to generate electricity and everything. Even in the transportation we can use the hydrogen energy. Now what about the challenges and gaps toward the circular hydrogen economy? In this case, actually, all the global looks to, by 2050, to introduce like a 10 million ton per year compared to the hydrogen produced currently in those years, to ensure that we are receiving or reaching that net zero carbon. But still we have some challenges we have to talk about them, like the waste and the cost management challenges. Still some countries, actually most of the countries, they face this challenges that in the hydrogen transport and the storage infrastructure still we could not, the requirement we could not achieve it. Also the safety and the environmental concerns, because the hydrogen, as I said, it's a gas, and when we store the hydrogen and we start to transport it, it has a high leakage percentage. It reached like 95% in the oxygen. And hydrogen, it is a low density material, and at the same time it is a flammability, which means it could be pumped. That means it is a dangerous energy. If we could not transport it in a correct way, it will be a disaster for the all human being. Okay. Semiconductors photocatalytic technology for the green hydrogen production. We are currently working on some of the photocatalytic material. It's a heterostructure based on the metal oxides such as titanium dioxide, tungsten dioxide, zinc oxide, and magnesium oxide, layered with a two-dimensional layer graphitic carbon nitrate from the graphene and its derivative. And the basic idea that we put those photocatalysis inside the generator, a photoreactor, and this photoreactor has been illuminated to a light source. We put some scavengers, and then what will happen? That the electron hole, they will be generated by absorbing energy from the solar cell. Just give me 2 minutes, please. Okay. And the electrons will be transferred from the valence band to conduction band, and then they are able to interact with the photocatalytic material to introduce splits actually the water from H2O into hydrogen and oxygen. Hydrogen economics in Kingdom of Saudi Arabia. Actually here in Kingdom of Saudi Arabia, especially in CAPSFARC, they are keep looking, and all the other sectors looking for new research that to increase the benefit of production, storage, and conversion of the hydrogen. This is aligned with the FIGEN, the Kingdom FIGEN 2030, and also it is applicable with the SDGs number 8, 9, and 10. I will not go through the details because we don't have enough time. But at the end, I need to talk about a little bit in my IWI lab. What about IWI lab at PSU? It's actually, what should I say? It's an amazing lab. It has been established since 1 year ago, and now, alhamdulillah, we have a lot of equipment. We can conduct our own research, and our research, they are in progress, alhamdulillah, like hydrogen production. In the case of the blue, we will produce the blue and the green hydrogen. We are working on the water treatment, absorption, and the photo degradation. This is a picture for the more advanced equipment that we have it now in our lab: XRD, Raman spectroscopy, FTIR, UV visible near spectrophotometer. And here are some of, it's a phone photos. We take it from our lab for the small instrument or equipment that we use. It's available in our lab for the microwave synthesis and the spin coating. Now, about the projects that we done it through the IWI lab in the last year, I have, alhamdulillah, done many publications. I have some of completed. There is some in progress, and alhamdulillah, I received one grant from Prince Sultan University according to the water treatment. And thank you. I hope that I didn't take a lot of time from your time. Thank you.
Thank you, Dr. Raja. Any question? You can ask her later.
You can.
Thanks for your nice talk. I would like to ask a simple question. What's the role of a scavenger in photocatalysis?
And the scavengers, actually, we add them in the photocatalysis to ensure that ensure what is the mechanism, the correct mechanism has been reached to achieve this kind of a production. Because different scavengers, some of them could increase the efficiency, some of them they will decrease the efficiency. The reason is each one of them is responsible about one reactive oxygen species that they are either trapped with during the photocatalysis or not.
Thank you.
Thank you. Okay, thank you to all.
Thank you, Dr. Rasha. Our next speaker is one of our colleagues. He's Dr. Ihab Shawish. He has finished his PhD end of last year, mashallah, and he published more than 10 papers and he has patent. And we are expecting a lot from him, inshallah, in the EWI lab. Dr. Ihab will talk about synthesis and characterization of novel S-strains analog of anti-cancer and anti-corrosion agents. Please, Dr. Ihab.
Okay. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. It's really my great pleasure to be here today to share with you some of the research projects that I have been engaged with during the past 3 to 4 years, which resulted in the publication of 5 to 6 papers, and I am going to talk about one of the patents that was registered in this year. The title of my talk is Synthesis and Characterization of Novel Estriazine Analogues as Anti-Cancer and Anti-Corrosion Agents. Now you may ask what's the relation between the chemistry and the chemical synthesis and the sustainability. And I do believe that the development of anti-cancer drugs and the drugs in general, it's one to protect and to improve the healthy practices of a human being. This is one of the most important goals and aspects of sustainability. In introduction, I am going to talk briefly about the structure of estriazine and why we selected estriazine to be the basic backbone to build our analogues. Then I'll proceed to the experimental results, and I will share with you some of these results. Briefly, I'll talk about the synthetic protocols and the applications of our derivatives, of our synthesized compounds, and the conclusions of these projects. Estriazine, as you can see here, it's a heterocyclic compound that's similar to benzene in its structure, with 3 nitrogens replacing 3 carbons. It has 3 structural isomers. The most important isomer is the first one, which is called the 1,3,5 triazine, depending on the position of nitrogen atoms. And also, it's called S-triazine, where S stands for the symmetrical structure, symmetrical geometry. It has shown that it has a very potent activity in many industrial and pharmacological applications. And we synthesized 4 different routes that incorporate estriazine in order to apply them to investigate their activity against different types of cancers. Estriazine is a very important moiety in chemical synthesis due to many characteristics. One of these characteristics is the availability. It's a cheap material. And also, it's the compliance in many synthetic protocols. We can start with the estriazine moiety, and we can synthesize different derivatives that incorporate this moiety. And I believe that the last one is the most important characteristic property for estriazine compounds, which is the wide spectrum of applications in industry and also in pharmacology. One of these characteristic importance and one of these significant applications of istrazine is the application in drug synthesis and in particular the treatment of cancer. Afan Allah wa iyyakum. Many commercial drugs that are used to treat cancer, they depend on istrazine as the building backbone. And before talking in little bit details about these structures and these compounds, I will just give you a brief idea how such type of drugs can be used to fight cancer. Here, assume this is a tumor cell, a cancer cell. The wall of the cell usually is combined with enzyme called EGFR. Now, if this enzyme is locked, there is no problem. The cancer cell will not be splitted, and the growth of the cancer cells will be in the minimum level. But the problem takes place when this enzyme combined with another enzyme called GF, the growth factor enzyme. Here, actually, the problem takes place, because this process will result on the emission or the releasing different signals, actually 5 signals, called the downstreaming cascade, to activate a series of enzymes like PI3K, ending with the 5th signal, which is very dangerous, that will result in the activation of this dangerous enzyme. It's mTOR. Actually, it's not dangerous, but in case of a tumor cell, this process is very unhealthy, because the activation of mTOR will do what? It will encourage the growth of the cells, and don't forget this is a cancer cell, so we have to kill this cascade. And also this enzyme will supply the tumor cells with energy, as well as it will enhance the survival of the tumor cell. So the role of the anti-cancer drugs takes place here from the first stage. If we can synthesize a chemical compounds that can block this series, terminated or eliminated, then we can say that the growth of the cancer cells will be reduced to the minimum levels. And acetyltriazine moiety, acetyltriazine derivatives are among these drugs that act in such type of cascades. Here, literature survey show many applications of acetyltriazine moiety. I here just listed a representative examples of anti-cancer drugs that used to treat different types of cancers, and all of them, as you can see, they incorporate the acetyltriazine moiety here in the blue. Here we have more examples of such derivatives. Furthermore, the literature is filled with dozens of publications and research projects that is talking about the significant importance of the reaction or incorporating different bioactive moieties rather than acetyltriazine. So if we succeed to prepare analogues that have acetyltriazine as the basic backbone, plus other bioactive moieties such as pyrazole, triazole, and indole. We have many others, but those which were selected, then we can say that such type of derivatives are expected to possess a potent and promising activity to treat different types of cancer. And actually, this was our driving force to synthesize, to construct the analogues of our research projects. We started from this compound. This is called cyanuric chloride, very cheap, available everywhere. It's the S-triazine scaffold. We started from this point, and we proceeded through 4 different synthetic routes by applying different synthetic protocols. In the first route here, alhamdulillah, we succeed to prepare a series of pyrazolyl acetyltriazine derivatives. Pyrazole is anti-cancer moiety, acetyltriazine is anti-cancer moiety. We conjugated and we combined them together, expecting that they will have a potent activity, and I'll talk inshallah about their application later. In the second route, we here again prepared a different type of pyrazolyl acetyltriazine derivatives by applying completely different synthetic methodology. And also here, we prepared pyrazolyl acetyltriazine moiety, but this time by including another bioactive moiety which is called indole. Here, it's indole. And the last one, it's a little bit different, the last route. This route was designed to prepare something called the spiro compound incorporating the styrosine. Spiro compounds are a family of chemical compounds with different cycles that share the same carbon. They have many applications in the cancer treatment and in the industrial applications as well. So in the next minutes, I'll just give you a brief idea about the scientific methodology of each one of these routes and the applications. How did we investigate the advantages or the expected advantages of our synthesized derivatives? So here I'll start with the first route. We started with cyanuric chloride, as we said. We conducted many steps. This is a multi-step synthetic route by applying the nucleophilic aromatic substitution. And the last step here, this is called intramolecular cyclodehydration to end with these derivatives. We synthesized about 12 derivatives of this pathway, and we also here we applied similar synthetic methodology to end with bis-pyrazolyl estryazine derivatives. Here we got the monopyrazolyl estryazine. Mono means one pyrazole moiety with estryazine scaffold. And there we prepared the bis-pyrazolyl, which means two moieties of the pyrazole. After that, actually in chemistry and in all sciences, synthesis just for synthesis, research just for research, to publish papers, it's good and it's important, but actually it doesn't have that much importance without applications. This is why from the first moment we decided to collaborate and to have a good relations with many institutes inside and outside Saudi Arabia in order to study the activities and the advantages of our compounds. So we did not synthesize these compounds just to say that we created a novel compounds. Okay, so what? We collaborated with many institutes in Jordan, in Egypt, in Spain, in America, in South Africa, and we sent our samples to the pharmacology and to the medicine colleges there in order to investigate the anti-cancer activity of these derivatives. Actually, we did as much as we can from something called in vitro studies, and we are now, inshallah, in the next stage, we'll proceed to the in vivo studies. In vitro means we studied the activity in the separate cell outside their living environment, and we did, this is the most important study, this is called the cytotoxicity profile. Just to give you an idea, here the cytotoxicity profile is measure the ability of the drugs or the synthesized compound to kill the cancer cells, and it measured by a scale called IC50. I know many of our colleagues are from different disciplinaries rather than chemistry and biology, but briefly, as the value of the IC50 increases, it means that the compound is less active. So we are looking for the compounds that have low IC50 values. And we compare these values with the commercial anti-cancer drug in the last line. This is called tamoxifen. If we compare, for example, the activity of derivative A54 against the cancer cell, the column in the middle, HCT cancer cell, this is the colon cancer cell, the activity or the IC50 value is 0.5, while for the tamoxifen, the commercial drug, is 26. What does it mean? It means that this derivative, our synthesized derivative, is about 52 times more active than the commercial drug itself. But it doesn't mean that it's more important than the commercial drug, because this is one of the factors. Actually, these promising results encouraged us to further investigate their biological applications and their biological importance. So we did many of these in vitro studies. Some of them are theoretical, some of them are practical, and alhamdulillah, I can say that we are very proud of the results, because all of these results support our initial assumption about the activity of our derivatives, and we published from this route 2 papers in good journals. And also, when I have joined the EWI lab, Dr. Bouidina informed me why we did not study the importance of these derivatives in industry. I told him, okay, I don't have that much experience in the industry, but I think the presence of pyrazole and the triazine ring, the pyrazole especially, it may be used as anti-corrosion. It can capture or it can catch the heavy metals, and it can be used for the anti-corrosion. We don't have the facilities yet in EWI lab. We are just to start. So I sent these samples to King Faisal University, and we collaborated with them in order to investigate their anti-corrosion behavior. And alhamdulillah, alhamdulillah, they informed me that the results were amazing, and we published one paper with respect to their application as anti-corrosion. And anti-corrosion, I think it's important in sustainability, because as I know, the anti-corrosion materials they can use to prepare the sprays in the petroleum pipes, and in the hydrogen transporting also, which is very related to sustainability projects. Next, the second, no, give me 2 more minutes, okay. Here also, just briefly, we prepared another analog of pyrazole triazole, but by applying completely different methodology. If you are interested in the mechanisms, in the steps, how did we prepare these compounds, I'll be more than happy to answer you in details, inshallah, during this forum. And again, we ended with different derivatives. We conducted the same cytotoxicity and the same biological studies, and alhamdulillah, all the results were amazing. Here we published one paper of this route. The third route also, we prepared another series of derivatives. We investigated their biological applications as anti-cancer treatment, especially for the breast cancer. The results were very promising, which qualifies such compounds to be employed in the synthesis of drug compounds. And we published also here one paper. The last, in 2 minutes, the last scheme, here we prepared, and this is very important scheme. We prepared the spiro derivatives incorporating the estriazine and the triazole moiety, and we investigated their applications in 2 aspects: anti-cancer behavior, and we preparing, the paper is in progress now, and this is the most important point. Again, we collaborated with King Faisal University to investigate their application as anti-corrosion inhibitors for carbon steel, and the result really was very, very promising, which encouraged us to publish one patent, which is now, alhamdulillah, in the final stage for the patent grant in the USA. In conclusion, estriazine is very cheap, very available, compliance in chemical synthesis. We proceeded through 4 different routes, and we prepared a lot of derivatives that showed that they have a potent activity as anti-cancer drugs and anti-corrosion materials. And alhamdulillah, we are very proud of what have been achieved until now. The recommendation for future now, we are looking for collaboration with external institutes to complete the biological investigation by doing the in vivo studies, and also to study how can we employ these derivatives in targeted drug delivery projects. And inshallah, we'll start very soon, next week, in the EWI lab by conducting such type of projects. Thank you very much. وآسف على الإطالة. يعطيكم العافية. شكرا جزيلا.
Thank you, Dr. Ihab. Any question?
ما اتفقنا.
You can ask first. Thanks for a nice talk. I'm also interested in photochemotherapy, and it's also an advanced technique used using several catalysts and to treat the target cell. And inshallah, in future we will have joint collaboration.
Inshallah, we are lucky to.
I have one question.
Between us. Yes.
I have one question. How to deliver the drug to the target site? Do you use any kind of carriers? And another question is that whether these drugs affect the normal cell or not.
Okay, regarding the first part of your question, we just investigated the activity outside the living system, so it doesn't need carriers in this stage. But as I told you, the targeted drug delivery projects, they are talking about how can we deliver the active material to the cancer cell without affecting the normal cells, by capsulations, by, for example, the polymeric micelles and different types of projects. We, inshallah, this is our next stage in the research, and it's one of my interests to learn such type of projects that inshallah will be initiated very soon within the LIWI, under the umbrella of EWI Lab, inshallah.
Inshallah. Thank you very much.
Thank you.
Just a comment. Thank you very much for a very interesting presentation, very interesting research work you've done. It's very impressive.
Thank you so much.
The work you've done, and I like you said, I looked then at applications, because without applications that reduces the validity and the importance of the research, which is very right. I am impressed by the number of publications you've made out of this, mashallah. Very well done. Thank you.
Thank you, Doctor. Thank you so much. Thank you.
Just to follow up, this is, I call magic compounds. But again, to follow up with Humayun, is about always when it's related to biomedical field, there is always side effect. I heard once that for drug delivery, usually when you have a new compound, it takes 10 years to deliver to the market. So because there are many protocols for safety, and especially for what we call side effects, you know. So the second question, just we talk, myself and Ihab and myself, sorry. So we talk about drug delivery. That means we use biomarkers. You know, biomarkers, they will, it's very selective. It means we can use like pH sensitive biomarkers. That means it can go to the specific target based on the enzymes of these organs. Just for clarification.
Yes, just a comment. Thank you so much. Thank you. يعطيكم العافية. السلام عليكم.
Thank you, Dr. Ihab again. Our last speaker for this session is Dr. Khalil Al-Rahman. Dr. Khalil Al-Rahman, one of the theoretical and applied science lab researchers. He is one of the top 2% according to Stanford ranking, mashallah. Dr. Khalil Al-Rahman will talk about numerical solution of heat and mass transfer. Please, Dr. Khalil.
From where we will, right? Assalamu alaikum. First of all, thank you for organizing such a great research forum and give us a chance to share some findings from mathematics department. See, if we talk about the motivation about the title, it's very difficult to answer a practical application when you are affiliated with the mathematics department, but it is fruitful. Like the question for the present talk is to answer, if you have a fluid which is moving over a flat surface or it is moving over a cylindrical surface, what will be the difference? If you are part of mathematics department, how you can answer for the one single fluid if it is moving over a flat or cylindrical surface? So in daily life, mostly we interact with the non-Newtonian and Newtonian fluids. Here in this talk, we particularly consider a non-Newtonian fluid, and that is a Kazan fluid model. And the question is that why we choose this fluid. So the motivation behind choosing this fluid is the Kazan in 1953 invented this fluid while working on ink for the printer, and further the application and the motivation and plus point of this fluid model is it can behave a solid and it can behave a liquid. And if you talk about the daily life example, a concentrated fruit juices, jelly, soap, honey and tomato sauce are the particular example of this fluid model. Further, one can use this fluid model to identify the properties of human blood. Owning all these importance, we consider this fluid. And now we assume a lot of assumptions for this problem. Like many people sitting are here from the physics department. See, if you ignore the assumptions, then actually you will move away from the reality. Like if you are working with the mass spring system or working with the pendulum, if you ignore the friction, actually you move far away from the reality. So we consider here a maximum assumption so that we can close to the reality. Like we focus on boundary layer flow. Actually, we are near the surface. A stagnation point is there. MSD is there actually to control the turbulence in a problem. Mixed convection, that we allow a conduction and convection at a time as well. Rather than to consider a thermal conductivity, this results a simple problem. We consider a variable thermal conductivity so that we have a good problem. Further, the inclined surface is considered to allow the role of gravity, heat generation, and non-linear thermal radiation are considered in this problem. So the geometry of the problem is the cylinder is inclined, the cylindrical surface is actually inclined with the angle alpha. We consider the strength of temperature at surface is stronger than the far away from the surface. And externally we applied a magnetic field, as I earlier told that we have to control the turbulence of the problem. Fine, let's have an interaction with the mathematics. So we construct a mathematical model for the previous problem. We have a 4 equations. The first one is actually an equation of continuity. This gives us a confidence that the influx and outflux are balanced. The second one is actually a momentum equation, and third one is the energy equation, while fourth one is again the concentration equation. By considering all these physical effects, we have a non-linear coupled system, and it's very difficult to solve such a coupled system analytically, so we choose a numerical method. And the way is that you have to introduce some similarity transformation which are given in equation 6. When we use these transformation, we actually are interested to reduce the system, and finally we reached at equation 7, 8 and 9. The 7 is the momentum equation and 8 is the concentration equation, while the 9 is the again concentration equation, and 8 is the energy equation. So here different parameters are involved which actually affect the flow. These parameters are, the first one is the Kazan fluid parameter. R stands for actually a radiation parameter, and the gamma stands for curvature parameter. GT and GC are thermal Grashof number due to temperature and concentration. Further, M stands for magnetic field, P stands for Prandtl. By owning all other parameters, we have 3 important surface quantities are there at surface. The first one is skin friction. Second one is a Nusselt number, and third one is a Chauvet number. Okay. We choose a shooting method to solve our reduced coupled ordinary differential equation. And for shooting method, first we have to reduce the system into first order differential system. When we incorporate equation 15 into our coupled reduced ordinary differential equation, what we get? A coupled first order ordinary differential equation. So by putting a self-coding in a MATLAB, we come to conclude the following results. The first one is the impact of a Kazan fluid parameter on a velocity. We find readings for 2 different surfaces. The first one is for the flat surface. The curves blue stands for the flat surface, and the second set of curves stands for the curvature. So one can see that when we have a positive values for the Kazan fluid parameter, actually velocity shows a decline trends. Same is the case for the figure 3, the impact of magnetic field on a velocity. What is going on when we say that we have a positive values of magnetic field? When you have a positive values of magnetic field, actually there is an increment in Lorentz force which is resistive in nature. So this force give resistance or offer resistance to a fluid particle, so as a result the velocity declines for the fluid. Further, if we talk about the temperature of a fluid, again the readings are noted for the 2 different surfaces, like the flat surface and cylindrical surface. The figure 4 represents the radiation impact on a temperature. One can see that the temperature shows direct relation with the radiation parameter. And the important thing is that the magnitude of temperature for the cylindrical surface is higher as compared to flat surface. And figure 5 represents the impact of Kazan parameter on fluid, on temperature. And we can see that again the Kazan fluid shows inverse trend for the temperature. Why it's happening? When we define the temperature as an average kinetic energy, in previous slide we saw that the Kazan fluid have inverse relation with the velocity. So when we increase the Kazan fluid parameter, actually the velocity reduces, or you can say a kinetic energy reduces, which results decline in temperature as well. Okay. The figure 6 represents the Prandtl impact on temperature, and you can see we have an inverse relation with the temperature. Actually, inverse relation holds for Prandtl due to inverse relation of thermal diffusivity. The figure 7 reflects the impact of heat generation on temperature as well, and you can see the direct relation between heat generation and temperature. Okay, we have some numerical data for skin friction, like the impact of magnetic field on skin frictions are observed for both plate and cylinder. We see that there is a direct relation for skin friction towards magnetic field. Same is the case for Kazan fluid parameter. Okay, the impact of radiation parameter on Nusselt number. When we say we commute a Nusselt number, it means that we are looking for the heat transfer normal to the surface. And heat transfer normal to the surface is actually in direct relation with the radiation parameter. Same is the case for Prandtl number. And if you talk about the shivered number for the both plate and cylindrical surfaces, we have inverse relation for these parameters. So if I can conclude myself, see, we mathematicians are open facilitator for engineers and all those people who are working in practical field. We cannot jump directly into the pool that this is the practical application of this work, this is the practical application of this work. We can just facilitate by giving our results so that they can perform experiment and focus on our results as well. So the conclusion of this talk is, whenever a people from engineering involved in some practical tasks, there is a finding from mathematics department is that when fluid is flowing from the curved surfaces, it will show higher magnitude for any parameter rather than as compared to fluid flow over a flat surfaces. This is the conclusion for my talk, and thank you for the concentration. Here are some references, and again, thank you for the concentration.
Thank you, Professor Khalil. Any question? Yes. Sorry.
You're a mathematician, Dr. Khalil, right?
I cannot claim myself as a mathematician, but on the behalf of mathematician, I can say.
But this is
yes.
Very much related to physics.
Yeah, related to physics.
So you've been collaborating with physicists recently?
Yeah, you can say actually when we propose some solution, we are actually working with some physical terms.
I liked it actually. Thank you so much.
Yeah, thank you.
Thank you.
Yeah, we use MATLAB. MATLAB is mathematics. Yeah, of course, but we solve it as a mathematical problem.
See, as I told, we have.
Yes. Yes.
Yeah. Okay, thank you.
Thank you, Professor Khalil. I think we come to the end of the session. We'll have a break for 10 minutes, and we will come back. Thanks again.
The kingdom. Something I've always found interesting is I always feel like there's a gap when we talk about sustainability between our public understanding of sustainability, what the common people understand as sustainability, and what actual researchers in the field think about it.
What do you mean by this?
For example, take the United Nations. They define, one of their earliest definitions of sustainable development was to provide for the needs of the present while also not compromising the needs of the future.
Okay, it's a nice definition, but I feel like it's like public definition of sustainability. Is there any specific definition for research sustainability in research? For example, during the coffee break, Dr. Budina defined sustainability as it's no longer for us to use, and it's no longer to make sense for us to use our resource once. So I feel like it makes sense for me, but it still is not research definition.
Yeah, absolutely. But I think it's a good step. I actually like that definition. I think, I think it makes sense that it comes from Dr. Bodina because he is the head of the EWE lab, right? So,
yes, one of the goals of the energy, water, environment goals is to use our knowledge and materials to improve the use of sustainable practices.
Well, in that case, I think it makes sense to hand over the session to him then.
Okay, sure. Let's welcoming the traveler scientist who travel while he's teaching and motivating. I don't know. In different 7 countries. Welcome, Doctor.
Right.
So, first of all, good morning and salam alaikum. So, I would like to congratulate our... this one maybe. So, I would like... Hello? Yeah. So, I would like first to welcome all our guests, of course, and our colleagues from PSU and from outside. Can you hear me? Or okay. So let me start this session. I would like first to welcome Professor Dr. Abdullah Sultan from KPFM. So can you display? So just to show short biography. So I would like to read the short biography more easily. So he's the Dean of Research Oversight and Coordination. This is very fancy name, Dr. Abdullah. So he will explain to us how they come to this name. So he's an associate professor in petroleum engineering. He has a BSc and master in chemical engineering and PhD in petroleum engineering from Texas A&M University in the United States. And Dr. Sultan, today's presentation is about research model at KPFM and the new role of the Deanship of Research. So let's welcome my colleague Abdullah. Thank you so much.
How much I have? 5-10 minutes? Yes. Yes, put it in a show.
So 10 or 15 minutes, it should be fine.
Okay.
Because we will have 3 presentations only for this time, for this session. Yeah.
Okay. So, Assalamu alaikum wa rahmatullahi wa barakatuh, and good morning all. Thank you very much, PSU, for the invitation, Dr. Muhammad and the whole team, and hopefully our addition today will be a positive contribution to this small workshop and gathering. And what I'll be interested to share with you today is what we have done on the other side of the kingdom at KFUPM over the past 4 years, because until 2019 we've been a state university like any other university in the kingdom. We governed by the same rule and regulations and systems, and 2019 there was a royal decree to have KVPM as an independent, standalone university, somehow similar to BSU, reporting to Board of Trustees. And since then we have done a lot of, dreams, been dreaming of them historically. We moved them to reality. I will focus my discussion today on research, and I hope I will be, toward the end of the presentation, answer sustainability from a research point of view. I hope I will be able to come up with a good definition. But historically, research within KFUPM is the ex-deanship of scientific research used to call for proposal, random proposal come from faculty. This proposal goes for peer review, and then being ranked and available funding, then we award faculty to keep their research. This model has been there for a while, and we felt based on our evolution in the university, this has to be advanced in general. And by revisiting the whole research model, because our mandate, connecting to your early statement, an early presentation and even other presentation, the fundamental research is also important, but what is it at the end of the day if we do blue hydrogen or turquoise or green, what is it at the end of the day? It has to have an impact, it has to be linked to the economy, it has to address global grand challenges that we as a humanity today facing. So this fragmented research that we are doing, I don't think we will take us that far. So as a result, we ask ourselves what we could do to improve more, and we came up with mainly solid 6 recommendations. One, we need to revisit institutional agenda in alignment with what happened globally, but importantly what happened in the kingdom. 10 years ago there was no Vision 2030 and where we are heading in the kingdom, and we need to keep ourselves agile in terms of expanding the impact, increasing the interdisciplinary. I think humanity and higher education, when we speak historically 80, 70 years ago, there were no boundary between discipline. You find the physicist, the last presentation someone asked the presenter, are you a mathematician or a fluid mechanics? Or these were not there over there historically. But discipline grow, and when discipline grow, they start building around themselves a boundary, and boundary became fence. And fence became battles. I mean, this is a mathematical domain and problem. Don't talk about if you are in transportation and civil or interdisciplinarity is critical and important. And I think most of the future problem that we are facing locally, regionally, and internationally, globally, it needs interdisciplinary team. You speak about energy, but social science need to be involved. You all other humanity, and I mean, it's not just only the science or the engineering or the medical school or the pharmaceutical school, and the collaboration. I think there is historically, and because of that growth happened globally. Academia, we're speaking about disciplines being in isolation, academic institution being in isolation from their surrounding. A whole academic institution. They don't speak the language of the industry. They don't speak language of the real need of the market, and the gap start being, I mean, big and big. And again, building the priority within the institution and moving forward in terms of less structure. I think that's what we found out in the last 3 years. These heavily structured organizations are pulling us back. When you have an organization that is highly structured, when you want to move a new initiative or you want to come up with a new idea, the structure is pulling us back. So our interest as an institution is to be more agile, more fast-moving institution, minimize the structuring. I report to 3 people. I report to the president, 2 vice president, and I communicate to. So it's not the single silos used to be historically. And for the first question, and I'll try to go fast in terms of defining what we're going to do KFUPM, we ask ourselves with all the changes happening, are we going to do what we are doing or we come to new area? In fact, what we are interested in is something high strength, historical strength in the university, and also futuristic in terms of the technology. And through this exercise, we almost read literally in the last 3 years every single document you could think of. Well, the vision realization program, all the strategies of the sectors in the kingdom, the RDI, we've been with them from day one before they even start. And even all the mega trend globally. Will it be the EU report or the UK RI reports or the SNF in the US or Department of Energy or the Chinese higher education model, and And we came up with areas that KVPM in the future will be. Some of them, those who are aware of KVPM, is historical at KVPM. Energy, oil and gas, materials. So historically being a strength, and it will continue as a strength. We introduce new disciplines like biotechnology, mobility, logistics, and the fintech in general, which is linked to our capability. But we will never have a medical school. We will not go into domain that historically is not our domain. Focus is also important to have an impact. And among these disciplines, if you take energy, for example, and we had a couple of presentations in the morning, take hydrogen, for example. Are you going to talk about the conversion or the pilot scale or the build-up or the catalyst or the conversion process or the integration of the system? What is it? What's the priority? To define that priority, we subject every possible area within those sectors, 10 sectors, to this triangle measure. How is it ranked in terms of the future and aspiration, including national security, RDI, connectivity, competitiveness in general, and competitiveness in terms of our capability to win, and the likelihood of success from the complexity of the problem, from the time, and anything came up within this zone in general, that the area, because there are many areas in energy, for example, we will not even interfere into them, because it is either capital intensive, it doesn't have a historical strength, probably another institution better than KVPM in doing it. So that's what the exercise. We will not do everything, we will do things that are relevant, it has an impact, it has a linkage with the national aspiration. And as a result of all of this, we transform completely our research and innovation in general by, first of all, assuring that all faculty member, if you are a faculty and you carry a title of a faculty at KVPM, research is an important. There were some interest from some of our colleagues to introduce teaching track faculty, and so if you are a faculty, you are a faculty. You're supposed to teach, you're supposed to do research, and to also contribute to the institution in an equal manner. Interdisciplinaries. No single program in the university, academic or research, is driven by a single discipline. No single program, even programs, academic program, is driven by a single discipline. We brought mathematicians with the physics, with the computer engineering, and we introduced, for example, the nuclear. And in the material science is driven by multidisciplinary. We launch centers, and the centers, again, they are not a disciplines, they are a thematic. So there is no center for mathematics or center for mechanical engineering, or the centers are thematic. Center for energy. Energy would need a social science, we need a mechanical engineer, you need a civil engineer, you need, so it's the thematic will bring, and we emphasize research to market, not research to publication. Publication is a byproduct. If you do research and you are excellent, publication is a byproduct by default. But it should not be the target. The target is what's the impact. Are you taking this research to market, either partially or fully, and ultimately startup? And we came up with a portfolio of 30 potential research centers. We launched so far, 20 of them are active. Some of those centers are on old centers. I mean, where is our colleagues who was talking about the chemistry? We had the corrosion center. We reshaped that center completely to become now advanced material, where corrosion is an element of advanced material. And some of the centers you see over here are new, like mobility, robotics, and to give you a scale of where we are in terms of funding, last year we were in the range of 100 and part of sustainability. I mean, because sustainability is the continuum in my opinion. If you sustain research, that means you must have this continuum. If you do good research this year and next year it collapses, and then the year after it grows, and then it collapses. So we are in the range of 160 million direct funding to research, excluding the cost of postdocs, excluding the cost of equipment, excluding the cost of graduate students. So these are a direct fund goes to either externally or internally in general. And we make centers are the center of gravity in research. So center is the home where faculty, students, postdocs, researchers, facility are all pulled in. I'm a faculty in the Department of Chemical Engineering or Petroleum Engineering. I can be associated with, for example, the advanced material. And I will access everything in the advanced material. And the resources are given over there. And our objective is to have the output strong and profound in terms of project, technology, collaboration, event, activity. And because if you compare this with the previous model, the fragmented, we used to have faculty working at their own individual level. But I'm a dean of research. I looked at the data for the past 15 years. We found that we achieved more than 1,000 plus projects. But if you look at what is the ultimate added value of those 1,000 projects, you cannot drag a niche in a certain area. Imagine if I bring a group of researchers and I direct them from the beginning. So we quantible our research funding in general, and we put the funding at the center. And if you are a faculty and you are affiliating yourself with center, you get immediate access to funding even without writing a proposal, faculty member in the room. Because we want our faculty member to experiment with their strange ideas, crazy ideas. They keep their research moving forward. And the second thing for our faculty in the room over here, there is no pocket money. All of the funding we are allocating, there is no pocket money goes into the research. It goes toward the research. You buy equipment, you buy material, you travel to attend a conference, you invite someone to come to your group. It's meant to be for research, not to be... And Dr. Muhammad, for your question, the Deanship of Scientific Research moved from being a front office that decide on faculty what to do, what not to do, to be a back office. We let faculty work, we support them, we enable them, and we don't dictate what they do, what not to do, but we oversight. And our role is to...
That's where the name comes from.
That's what the name came from. And I think this is important because in many cases we feel, because you bring brilliant people, faculty, this talent, and then you dictate on them what to do, what not to do. The beauty of higher education, you bring the best people and support them and leave them alone. They will do wonderful things in general. So our role is to be a back office, support them with postdocs, with funding, with conference attendance, with award, with recognition. Whatever they need, we avail to them. Of course, it's regulated. It's not an open, but that's the role instead of being that front office in general. The latest addition to connect the dots, and especially with the industry, we are launching consortia. You are coming from Europe, and you are familiar with the concept. What slightly we are doing different from the common consortium model is this is not a university-driven consortium. This is a member-driven consortium. So we are bringing government entity, big industrial end users, SABIC, Aramco, Raytheon, Boeing, whoever, the big end users, technology developer, the company that develops technology, IBM, Google, Dow. These are examples. I mean, don't take the logo as... but just brought an example over here. And university. If we strike a relation with BSU or with CACS, for example, rather than to be random, sporadic, it has to be on a thematic. And this thematic is part of a bigger movement. And we launched 2 consortia, one in hydrogen.
Abdullah,
yep, I'm done.
One? Okay, great.
One in hydrogen. And I'll add 2 colors to your colors. So we are talking about the turquoise and the gold. And the kingdom is among the country moving forward the gold hydrogen in general. Gold from the meaning, that means it's precious. That means it's an underground existing hydrogen, by the way. And we have a lot of potential reserve of that. And also we streamline all the commercialization. From if you have an idea, you are a student, you are a faculty, you are a researcher, you are a visitor, whoever you are working in this ecosystem. And to take that idea from an ideation to commercialization, we streamline completely the process with our entrepreneurship, with our funding, with our Dhahran Techno Valley partners. And so in summary, we have achieved most of what we been aspired to. And if you are looking for any information, you can scan this barcode to read more on our research and innovation at KFUPM. And if you are interested to go in a very specific information, you can probably scan the other barcode for last year annual report for research and innovation with the university. I hope I made a big...
Yes, you are on time. So thanks, Dr.
Thank
Abdullah,
you.
for this insightful presentation. So I think we will leave the question during the discussion. It's much better. So I will invite my colleague Hussam. He's the general manager of Energy in the Future, or the Future in the... There are new names, that's why I'm not used to these. So he is general manager of the Future Energy Institute at CACTS. He has a PhD in electrical engineering from the University of California in the United States. And he's with us to replace our invited speaker, Dr. Abdullah Al-Khudr, who is the Vice President of Sustainability and Environment at CACTS. So welcome our colleague Hussam. Sorry.
Yes, so thank you so much, everyone, for having me here. Thank you, Professor Mohammed. I didn't have a presentation to share.
Yeah,
I
that's
understand
fine.
this is a panel session format,
yeah.
But our friend at KFUPM always innovative and always creative. So I'll just...
the mic. There? You can see it if you like, yeah.
Oh, okay.
Yeah, just use the mic.
Okay, do you hear me good now? Okay, so thank you very much, Professor Mohammed. Thank you very much for the organizers. It's a tremendous honor, actually, to be among this group and among this panel with Dr. Abdullah and my colleagues. It's actually also a tremendous honor for me to be here at this school at PSU. I think it's a champion of when it comes to sustainability. The energy, water, the EWI lab is very famous for its work, and the school is it's championing sustainability. It is only fitting also, I have to mention, when I was reflecting last night, when the VP told me that he will be giving a talk tomorrow at PSU on his behalf, Dr. Abdullah Al-Khudr. He had some other commitments, and he apologized for his attending. But when I was reflecting on PSU, and also I'm honored also to talk here because it's holds the name of a key national figure, Prince Sultan. His work in charity and sustainability, and the amount of sustainability that charity requires, that needs, we see organizations that goes for more than 10 years and decades. Yeah. That links to His Royal Highness. May God have mercy on him. So that's what I'm reflecting. That's an honor. I come from CACST, and maybe I present in the topic of research sustainability. Our friends here mentioned that it has different definitions. The concept of sustainability. So meeting the needs of the now, but not compromising the needs of the future. That's what you mentioned. But I think it's also in line, the same definition is in line with research sustainability, because if we think about it in terms of opportunity cost of the future, we have to do something so we cannot compromise the future generation. So we have to do something now, or we have to invest now, or we have to spend now, not to compromise the future. So it's kind of a reverse concept, but I think it's the same definition for sustainability. I think CACST, we share the same age, CACST and KFUPM, around the same time we have started. I think it presents also a good case study of research sustainability. Throughout our 45 years of research at CACST, we have gone through a lot of changes, a lot of phases. We had many good times, golden times. We had a lot of funding at certain points. We would support a lot of universities. We would support a lot of groups. We would start flagship projects that cost hundreds of millions of dollars, sometimes even in, if I remember, in military complex research, we would go even to the billion regime. We built labs. We started partnerships with reputable organizations such as MIT, Harvard, all the top schools from the U.S. We have built a human capital that is coming from these universities that we sent them for scholarship there. So these are our golden times, but actually we have very, very challenging times, and the challenge was basically how to sustain these successes and how to sustain these labs that we built, how to sustain these projects, flagship projects that we started, how do we have a retention for the human capital that we have building for so long and not to leak to the market or to the other organization, for example. So sustainability is very important, and but in the past few months or the past couple of years, we're starting change is happening, and we are seeing a lot of issues that is being saved, actually. In short, if I want to put the 45 experience in one sentence for CACS, I would say better governance makes for better research sustainability. If I just make it in one sentence. And 45 years, better governance in line with the existing and establishing practices rather than just everybody coming out with his conduct or the protocols or governance, ad hoc governance. So that's what we did actually in the past 2 years, and our sister organizations such as KPPM.
I think I would like to leave this for my questions because you are answering my question already.
Oh, I see. Okay, I didn't see your question.
Thank you so much, Hussam.
You're welcome.
So let's now call Dr. Abdel Hamid. So our colleague from Al Faisal University, he is the Director of Research and Innovation at Al Faisal University. He is an Associate Professor in Electrical Engineering. He holds a PhD in Electrical Engineering from Queen's University in Canada, and where he is now Adjunct Professor. So his talk is about Al Faisal Ecosystem for Education, Research and Innovation. So welcome, Dr. Abdel Hamid. Presentation, please. Yeah, is that Hamid?
No, can Hamid, I have a presentation.
Hussam, you will answer most of my questions. لو خليتي تتكلمي answer my question. تعال العب. This is a good example.
All right. Assalamu alaikum. So I'd like to start off with expressing my appreciation for having me here today. On many days, one of the things that happen is that I get to know what PSU is doing in terms of research or management, and the thought that comes to me is that we should have thought of this first. So you guys take the lead in many, many things. And I don't know what is the English word for the, I don't want to say envy, but I think the Arabic word would be غبط, بنغبطكم. I don't know. So it's the good kind of envy on the many things that you do. Today I just want to talk about where we are at with the Al Faisal University in terms of managing the research and in terms of setting the direction as to how to go forward. And that's why we get to call it the ecosystem for education, research, and innovation, which is what gets to be overseen by the Office of Graduate Studies, Research and Innovation at the university. Just a quick introduction about Al Faisal University. We started off in 2008. This year happens to be the year we're celebrating 15 years of operation. Of course, in conceptions, a lot of the elders at Al Faisal University would tell you that the idea started a bit earlier from that, but we started admitting students in 2008. Where we're at right now is that we have 6 colleges: medicine, engineering, science, pharmacy, business, and law. And we also have a graduate schools where at the moment we have 28 programs, and the number of programs is increasing. We've been having the good fortune in terms of the ranking, both in terms of Times Higher Education and the U.S. News, especially for the College of Medicine. And the mission that we have from the start, in addition to the excellence in teaching and the services, is that we wanted to have a good focus on research, meaning that we wanted to give back and be focused on work that is tangible, that is relevant to the community, and that has an impact on how things are going. For the Office of Graduate Studies and Research and Innovation, this is kind of central to what the stuff that we get to do. And so over the years, we did not have a structured way of doing things similar to the situation in KFUPM, and I'd imagine in many of the institutions out there, is that you let things go for a while and get to see how things work. You invest sufficiently in the basic research. When chance comes and you have something that is worthwhile, you pursue it, but you do not have a systemic infrastructure that actually gets to pick up ideas on the go and have it. So what this resulted in is that by now we have around, and this is counting since conception, is that we have 3,800 publications with an average of 2.7 per faculty, and I think this is a reasonable standing among the universities in the kingdom. We have 43 patents up to date between fully owned and shared, some of which were shared with Aramco and some of them shared with international partners. We have recently, and we'll talk about this in a bit, introduced our commercialization pipeline. Readily, we have 2 startups that are started, both of them in the medical side of things, and we have 2 incubators, one of which is in the medical field, and the other is what you get to call an educational technology incubator, which is an incubator / awareness raising incubator that gets to be directed at undergraduate studies. We have a reasonable amount of consultancy-based income and research income coming from external projects. You and us are private universities, and you understand the struggles that comes in terms of funding private universities from governmental institutions. So we have to look into industrial partners and commercial partners to look into that. So, but we've been managing things okay. And so we get to do things through networking, we get to do things through consultancy input, and we get to do things through having really, really good work. So in the streamline of things, where things start, we start with the education part. Of course, we have the undergraduate education going on, but we also have the graduate studies. And because of the solvency question, and because of the emphasis on efficiency in our private universities, you really have to be aligned with what the market needs. You don't have the luxury to open programs that do not have students coming. And so this is one of the things that come along. For research, we allow for ideation, we allow for exploration, and we then have the commercialization pipeline where we materialize things. I will go over this step by step, but I will not be spending a lot of time this. I know I have a 15-minute limit.
Less than 15. I reduced by 5 minutes.
Right now. So as we said, the graduate programs get to be introduced in partnership with the either agencies of interest, which is either the Ministry of Health or the Institute of Taxes, but they're very directed, and they get to be launched and survive based on the interest. And we have them aligned with the themes which I will be discussing shortly. So this is stuff that gets to feed the areas of interest that we have in the universities and the direction of research that we have in the university. So for ideation and exploration, this is where the research programs and initiatives takes place. And what we've done over the last year and a half, so this is starting from me joining the office but also working with team, is that we began an alignment exercise looking both outwards and inwards. And the idea is that to look at what is it that not just we're interested in, because it's easy to get to be interested in everything, but what is it that we are good at, and what is it that we can actually contribute to with the resources that we have and with the abilities that we have. And also we have to stay relevant. And over time we got to align these the themes with the RDIA, with the Ministry of Education, input with the SDGs, and so it's a continuous thing. And we have to, but what we are allowing for a cycle of 2 to 3 years in order to review this and see the productivity into the different areas. Along with this, we had a look at our intellectual property and commercialization policy, fully revamped. We introduced the Technology Transfer Office. We began our connections with the Saudi Authority for Intellectual Property, and we began to introduce or streamline the commercialization aspect. And this is where a lot of work is already in the pipeline, in addition to the 2 companies that has graduated. We have a business front, which is Al Faisal Center for Research and Consultancy. So this is where the consultancy request comes in. This is where the commissioning aspects comes in. Access to materials, access to facilities, access to all of this, in addition to the IP licensing. This is the front that we have for all of these. Now, coming out of the themes and coming out of the interest, the thing that happened during the themes making exercises that we began to notice the synergies between the different colleges. So we get to see people in industrial engineering talking about the same thing that is happening in College of Business. We get to see people in College of Medicine interested in things that the AI people and the data people are able to contribute to. And so we began to move above the themes and move into what is called the initiatives. And we started off identifying 4 initiatives: the health innovations, the advanced manufacturing, human capital initiative, and the sustainable development. At the moment, we've managed to launch 2 of these, one of which is in the health innovations. And the areas of interest in there, you get to see that between purely medicine and purely interdisciplinary sciences. Similarly for the advanced manufacturing. And all of this is based on an infrastructure that is already there, whether the AI center that we have, the advanced manufacturing, the Internet of Things research lab, or the biosensors research labs. All of these are based on the things that we have. So in addition to the Alpha High, we have the advanced manufacturing. What happens over here is that in addition to the pipeline for basic research, which happens through the internal research grant, we began to have what is called the President's Innovation Funding. And this is a 10-fold investment and funding opportunities that is offered to teams of researchers with technology at the minimum level of a technology readiness level between 3 and 4. So you get to target things that have the sufficient maturity in order to proceed to commercialization, or at least a serious commercialization. So clean things up just for an investor to come along and pick them up. We have some national offerings. I will not go into the details of this, but we are specifically proud of our centers targeting governance and targeting competitiveness. These are analytics-based centers that looks into things such as the governance index or the competitiveness index in the country. The high-level deep technology incubator that we have is aimed at biotechnology. And finally, we have an overarching Center for Analytics and Visualization. This is a core service that is serving the entire university, and it's also open for consultancy services to the outside. Now, in terms of assets, one of the things that got... You have 2 minutes. I have 2 minutes, and I need only 2 minutes. So in terms of assets, we have the faculty, so we have most of them coming from outside. We have around 500 students in our graduate studies between the 2 years and across the different programs, and we have a support of around 100 people. So this is a small kind of operation, and we're able to do much with that. As I said, the solvency question makes us do things efficiently, but it also makes us do things quickly. 6% of the budget gets to be redirected to the research. For the external funding, we redirect 70% of the overhead directly to the research infrastructure that we have. In addition to this, we are motivating the what is called the extension portal, and we've been in agreements with KLD and Coursera in order to support the Arabic content, serving the increase of the local Arabic content and the local content in the country and internationally. And right now, I think we're around 1,000 courses that are offered to training to different institutes across the kingdom. Finally, none of this can be done in isolation, and none of this can be done in silos. We have a good network of partners, whether it's across the academics, the health, unit because of our College of Medicine, which is our most prized college, government agencies, and also industry. So this is how we get things done. And of course, we're open for further opportunities. We'd like to have PSU's logo over here and other
in the near
logos.
future.
Yes, absolutely. That is it. Some of the links that you can use in order to access further information. And thank you very much.
Thank you, Dr. Hamid, for this insightful presentation. So let's welcome our colleague, Anis. He's the Director of Research and Initiative Center. He is also the Director of Riot Lab, and he will give us a presentation about the success story of PSU in research and innovation. So we are sharing different experiences.
So I think I don't have too much time, right?
Take 10 minutes, please.
Okay.
At maximum.
I'll make it less, no problem. So, Assalamu alaikum wa rahmatullah. I'm always actually proud and happy to present our experience at Prince Sultan University on how we have built a research ecosystem that we are all proud of. I'm going to present our research in numbers, but actually what I'm proud of beyond numbers is the ecosystem which makes every person or every researcher happy at Prince Sultan University, which is more, for me, it's better than the numbers I'm going to present, which are also very good. So a few years ago, we started to identify some of the challenges that probably we're going to talk about them about our research ecosystem, and we identified why we didn't actually excel in the way we wanted to be. And we identified some of the challenges, like we had a centralized decision-making system, which is probably common to many of the universities here in Saudi Arabia or also outside. So we had also limited infrastructure for scientific research in the way it should be, actually. The research leadership was not at the level that we expected, and the funding also was questioned at the time, and also lack of research labs. And we have adopted a completely transformative strategy to change the research ecosystem at Prince Sultan Universities, and I have summarized them in 4 actions, although there are many, many other details. So the first thing that we started with is actually to decentralize the decision-making. It shouldn't take time for a faculty member to go to conference waiting for example, university council to take decision after a couple of weeks or probably months. And now the decisions are taken at the college level. So usually I'm just giving an example. A conference application should be processed in less than a week in most of the cases. And also we tried also to make a complete marketing of our research, independence of the decisions. Of course, these decisions are regulated by 3 bylaws, transparent, available even on our website. Everybody can access the bylaws, and they are applied very smoothly here at the university. And also, we made a completely financial analysis system, a complete data analytic system, information system that we have developed, because everything has to be tracked. Every transaction, every publication, every patent has to be tracked. So we built a complete information system from scratch now. For example, if we need any information about the research, it's immediately available. And this is one of the things that actually matters a lot for having a sustainable research ecosystem. We have also created a program to attract distinguished researchers. We have 7 programs, starting from visiting professors, postdocs, visiting PhD faculty members to fill some of the gaps, senior researchers. We have different categories of researchers, starting from research engineer, research assistants, different type of categories that we have created. And now we have more than 60 full-time. I'm saying full-time. They are not doing research, teaching, or they are doing administration. They only do research. 60 full-time researchers from different backgrounds and different disciplines and different categories. And one of the most initiatives are the research labs. So the research labs represent the identity of the research at university. And this is as opposed to project-based research. So project-based research, it means that probably university is going to provide the funding. They are going to make a temporary group of researchers as a research group to solve this project. And finally, when the project is over, there is no research team. So there is no identity, basically. Now at Princeton University, we have research labs. They are independent of people. If anyone leaves, the research lab is always there. This is a theme. This is an identity of the research at Princeton University. So these are the main strategies that we have adopted. And as you can see, the evolution of research labs over the year, we started from 0 in 2016. We have now 24 research labs and groups altogether. And these are the different types of distinguished researcher programs. And these are the different research labs. You can see we have an even distribution of research labs among the different 6 colleges in computer science, in College of Law, in College of Business Administration, Humanity and Science, and College of Engineering as well. And you can see the impact from where we started in 2018, okay, and the transformation started in 2019. Now we have almost 6 times more publications than when we had before. And we don't care only about numbers, we care also about quality. And this is why we tuned our bylaws to push people to publish in only high-venue journals. And this is why we have 83% of our publications in best venues of best journal venues. The publication per faculty increased from 0.4 in 2018 to 3.36 in 2022. And it's even now more in 2023. We have just before the middle of the year more than 570 publications. So this is actually, of course, Princeton University doesn't have thousands of faculty members, it's only a couple of hundreds. And with this, we've published 1,100 publications last year. And it makes us actually on the top just after KAUST. KAUST, of course, it's a purely research institution. They have 16 publications per faculty. We're having 3.36 publications per faculty. This data is obtained from official sources, from Scopus database, and also we collected the numbers of faculty members in each university from available sources. Also, we have different type of distinctions. So we have 27 of university members as ranked in the Stanford list of 2% scientists. We have one also who is ranked in the top 1% scientists in the Web of Science. 7.4% of faculty members are internationally recognized by several ranking systems. Also, another thing that we focus on is to involve students in research. And you can see the evolution of publications. These are publications that we do in journals that involve students. So now we have more than 129 students, cumulative number, who were involved in research publications. And this is because we have established research labs. And research labs are incubator of skills. So whoever student would like to improve himself or herself, she can join the research lab and get involved into innovative research.
You have 2 minutes, Anis.
Yeah, I finished. Now we started to look carefully at innovation, because when we have maturity in terms of academic research, and as my colleagues already mentioned, we don't want to have only research for publication. We want to have research for money. So we would not only like to count the number of publications, but we would like to count the number of millions that we can bring for publication. And this is something very challenging that probably we are going to discuss now in the panel. And we're heavily working on this. We are now also heavily working on patenting our inventions. We have 9 US patents. We have also started to file a couple of tens of patents in the Saudi Authority of Intellectual Property. And we are working on closing the gap with industrial collaboration and also entrepreneurship. Okay, thank you very much. And
thank you, Anis, for sharing our university experience. So now we will start our panel discussion. I have a few questions, so I will ask, and whenever panel he will share the respective institution experience. So the first question I would like to share with you is, what are the challenges facing research in your institution in order to align with the Kingdom RDI, the novel RDI, strategies, Vision 2030, and globally the SDG? So who will start? I think Hussam, he will start first.
So challenges, of course. We share a lot of challenges with our sister organization in terms of funding, in terms of, as I said, governance, in terms of alignment with the national needs and priorities and stuff like that. But I would like to take this chance. I don't know your questions. Are you going to ask about the RDI priorities later on, or
Yeah. No.
or can I explain it?
You can explain. Yes.
Yeah, let
I
me
think
explain.
will-
So, because this is very important,
Yes,
I would like to
exactly.
introduce to my colleagues, because I've seen research going on, and I've seen people talking about hydrogen, people talking about CPVs, people talking about Dr. Ofa, Dr. Rasha, and Dr. I'm
Ihab.
sorry about the name. Ihab, yes, and Khalil.
And Dr. Khalil.
Yeah. So we have 4 priorities. The RDI aspirations that was set by the Crown Prince last June 2022. Now we have 4 priorities: the health and wellness, and leadership in industrial and energy sector, and environmental and sustainability needs, and economies of the future. Basically, the target of the government to spend 2.5% of the GDP on RDI. Now, in order for that to happen, it will take a little bit of time. We have asked not to receive that 2.5% right now.
Straightforward. We are not ready.
We're not ready. It's going to crash us. It's going to crush us, of course. So we must be ready. That's one of the challenges. So we are racing with time to be ready with the government. The government is really, really moving forward very quick. So to my friends at PSU, to our friends at KFU, to our friends at Faisal, and to other organizations within the kingdom, align with the RDI. I've seen Dr. Abdullah mention that in the beginning. It's very important because as we hear from RDI people, and Dr. Munir Tsugi is building the team there, basically not a single penny will be spent on RDI without being first aligned with the national aspiration and, of course, with the approval of the RDIA. And in order for that, of course, to happen is you need an alignment. So this is a major issue. Basically, every institution, every organization, or every professor maybe, or every researcher could look to his work, to his research, and ask himself, is it aligned? Otherwise, if there is extra fund within the institutes or in the universities that can be spent on blue sky research or thinking, that's up to the organizations.
Thank you, Hassam. So let's share. Who wants to? Dr. Abdullah or Dr. Okay, we can continue. Yeah, Dr. Abdul Hamid, please.
So I think one of the challenges from the perspective of private university is that things are moving at a rate where, in order for us to be able to sufficiently responsive, we have to actually begin to really prioritize to the extent that things might be at a loss at one stage or another. And I think this is both good and bad. I think the good aspect of it is that it helps us focus. No one university can be good at everything. Yes. The fact that we have to make a choice about what is it that we can really be good at, what is it that we can bring forward. And it also has made us consciously aware of the possible partners that we can have moving forward. Over the last 2 years, we've seen much stronger links with our neighbor hospital. We've reached out to KAUST, we've reached out to other universities. And the point is to not bear the burden of resources and facilities ourselves, but rather we have good scientists, we have good support that we can offer, and we get to do that. So I think this is how we get to view things.
Yeah, so it's like another way. It's like we should be more focused using our strength.
Absolutely.
Exactly. So now let's share with Dr. Abdullah the experience of KPVM.
So from KPVM point of view, we believe and we think that the big challenge facing us ahead is being resilient enough for you guys, better than sustainability, because resilience is really I think a better word in comparison with sustainability. You could sustain yourself or operation or system, but you are in the wrong direction, and you could sustain it but the resilience is the self-adaptation and self-correction. and recorrecting and moving forward. So we believe one of the key challenges being resilient enough to address the major funding coming from the government. And the expectation is for the institution in the kingdom to deliver fast. We built probably among the early institutions in the kingdom 25 years ago an ecosystem for taking research all the way to product and development. But looking forward, and I think we've been down significantly because literally since 2017 until today there is a zero national funding coming to university, and as a state in large I think that's one of the real critical downtime for us in the kingdom. We're relying on self-resources, on connecting with the weak industry. I would say it with no reservation over here. I think among the big giants in the kingdom, with the exception of Sabiq and Aramco, there is no other major industry funding. So if in university, like private university, looking for funding, who's there out funding? It's not the ecosystem in the US or in Europe, or where even the small incubated company, they subcontract in China and they want to do cheap research. And so I think this is, if you want me to speak frankly, I think this is the real challenge facing university in absentia of a national funding. And hopefully the new RDI, the new national funding now will really drive university right, position them in a competitive way, so in the kingdom inshallah to be among the key contributor to knowledge globally. Thank you.
Thank you, Dr. Hassam. Let's see the view of our colleague Anis.
Okay, yeah, so I agree with my colleagues. So I would say there are three main challenges. The first one is the funding, and especially for private universities. I have been working before in a public university. I was less probably mature than now, and I was able to bring more release than I can actually bring it at this moment. And I think private universities actually are struggling, not only Sultan University, but are struggling of getting government fund or industrial fund. The second issue is the industry collaboration, and I said this many times. Industrial companies or companies usually are not mature enough, and there is no something that will push them to collaborate with the university. They consider university as free cost labor just to drive some research. We had several experiences with the industrial here. Some of them were successful to some extent, but let's say the majority were not at the level of expectation. So I think the government should do something for companies to push them. I think there was some recent laws that will incentivize companies to put money in R&D. That will also help. Another thing, and this is probably something related to Prince Sultan University, is closing the gap between the academic research and the commercialization. This is some of the most challenging experience that I have been facing as a director of research. But alhamdulillah, we've done good steps to move forward. Yeah. And I hope to close this challenge, because I think for the sustainability of research, you need to bring external fund. Now, the university is generous. They are providing sufficient resources, but this is not sustainable. We don't know if there is any economic issue that is going to come after a couple of years that will impact a lot. So if you don't have external resources, if you don't have a variety of resources from where you can bring money, your research ecosystem is not sustainable.
So thank you, Anis. So I think Hassam wants to say something about Anis.
So it's about Anis, and I think it's a point that I think everybody will mention. Yeah, there is a lack, or I think, sorry, not lack. I mean, but as Dr. Abdullah mentioned, yeah, 2017. Since now, the funding was a little bit down. But I think we have to reflect on ourselves sometimes, and we have to ask ourselves: is it the decision maker sometimes, or the machine that makes or that funds would ask sometimes, what is the impact? Usually, I have been meeting with Chad Merkin. He's a winner of King Faisal Prize last month in sciences. He's from Northwestern University, and I had a meeting yesterday with him. And he alone had generated 30 companies in Northwestern University, and these 30 companies, only one of them made $2 billion. $2 billion in income or impact. So this is, I think, the mentality that goes. Yes, funding will go there, but and papers are very important. I'm a scientist. I've done a lot of papers. I've done a lot of papers at UCLA. I've done a lot of the papers in my PhD. And after my PhD, until now, I'm doing my paper. That's my patience. That's my passion. But in the hydrogen, for example, Dr. Rasha, are you, for example, looking toward reducing the kilogram per, the dollars per kilogram for hydrogen? Is that your goal? Are you going to achieve that? Do you have milestone to reach there? So that's, I think, the type of question that is going to be asked, or how this funding is going to be funneled. Dr. Wafa, for example, is this integration between CPV and electrolyzers, this exact technology would aid better economics for hydrogen? Do we change, for example, different electrolysis? Do we change different technologies for photovoltaics? Are CPVs a little expensive than regular PVs? So these kind of questions that will help us as a scientist. Now I'm putting the hat of a scientist, not the hat of RDIA or the CAC. Putting the hat of a scientist, this kind of question that we'll be giving and they will be receiving, and we have to answer for. So just because I'm addressing the same point from my colleagues here, it's funding. But sometimes we have to reflect.
So you drive me now to discuss this critical point, which I think myself I'm facing here when I started to join PSU. It's how we can make or strengthen or make successful partnership. I don't say collaboration because we use a lot the word collaboration. But I prefer to use partnership between academia, and academia industry. So this is a lot because all of us has experience in the world that when we were postdocs, all our projects they involve industry. For example, when I was in the UK, 2 projects I worked. All of them, if you apply for EPSRC, now they can change the name. If you need to get a recommendation support letter from industry, and 50% of the projects come from the EPSRC and 50% from the industry. So this kind of organization may help in the future. So, what is your opinion about this? How? Myself, I find difficulties to establish collaboration even with academia. She knows, Doctor. So, and with company is more difficult. So if we don't reach how we can collaborate, make partnership, it will be difficult, to drive our research into economic impact.
I'm sorry to take much of the time, but because I have information to answer for this, and I'm connected to the RDI people a little bit, I think that's the model. Everything is not yet official. It has to be launched by the Crown Prince, the RDI vision and mission. But I think one of the points that is being discussed, how could a mission or a moonshot that we call, for example, let's say hydrogen, the hydrogen moonshot, for example, if we want to reach $1 per kilogram by 2030, for example. That's the moonshot for us. Is your research going to save that? It is going to be one of the models that is being discussed is the same model as you mentioned, Professor Mohammed, is, for example, to air product from our friends at Dahran Valley, Dr. Valley, the air product, for example, or Qudra, they can champion this mission and they can fund a little bit of it. And the government also could do the 15%, or even now they're thinking about 80-20%, for example. And in partnership with the whatever G2B or G2G or academia too, if you want to put it academia too. That's a model that is being discussed. So I think time will tell in a few months ahead.
Who can interview? Anis, okay, go ahead.
Yeah, I have just a comment about things that you've been mentioning, that if we do research, what's the impact and why it's not commercialized. So my question is, commercialization and making the impact, the financial impact, is it the role of the researcher or the role of other parties? Because sometimes we blame the researcher, so the researcher is not making an impact. That's not true. I'll give you an example. What's the best research university here in Saudi Arabia? KAUST. KFUPM. KAUST and KFUPM. Both, yes, I agree. But I visited KAUST. And I went to one of the labs that are producing prototypes for like COVID-19 investigations. And I met with the professor. He said, I don't care about commercialization. He said, there is here a technology transfer office, and they are going to hunt any kind of this innovative idea, and probably they will sell it, but I don't care. I provide technology. I don't provide product. He was very clear about it. And he came from the US, he spent a lot of time, a lot of experience like all other KAUST universities. So if we don't find an impact on research in some of the universities, we need to check whether the university policies and processes are made to create that impact. It doesn't mean that the research by itself is not good, but probably it's not put into another level where it has to be commercialized. And commercialization is something very, very challenging. I mean, there should be, because it involves several parties, it involves money, and when money is in place, trouble is going to start, it has to be very well strategically planned. Yeah, it's not only commercialization, but that's one of the most important KPIs, because if you talk, if you talk about innovation KPIs, there are two main. How many startups you made and how much money you brought. These are the two main KPIs.
Let's hear Dr. Abdul.
لا تضيق واسعا. I mean, impact can be measured by licensing, by adaptation of an advancement that you have developed in a lab, in an existing process, and it helps in efficiency, increase. So it's not just only commercialization. And I think university need to move closer, and it's not the role of university to do the commercialization. Yes. It's a whole business out there exactly. to do it. We are on agreement on all of this.
Yeah, that's what we mentioned.
But I had this argument with our colleagues in the university, and many of them, they admit, I told them, don't you think if you see the outcomes of your research lab and graduate student being highlighted in the industry or adapted by a company, isn't that a big success? They said, yeah. I told them that's what we are talking about, impact. It's not just you write the paper, you throw it, and okay, I don't care who take it, or that include marketing of your research, connecting. There are embedded things that faculty will do to carry on the momentum and clarify the impact of their research. There are a lot of beautiful ideas happen, but nobody knows about them. Because the researcher published the paper, through the paper, and okay, I don't care, someone else take it.
So we are talking about numbers, not impact. Now let's hear Dr. Abdul Hamid. Opinion, please.
So there's an aspect of this that I think is often overlooked, which is the aspect of culture. One of the pleasantly surprising things about the RDIA deliberations is that we found them talking about the need to train research personnel, research management personnel, and we found them talking about legislations and regulations. And I think there's there's still a persistent misunderstanding, is that there is this faculty that is able to develop the research, think out the project plan, think out the commercialization aspect, bring it to the market, and all of such. There needs to be an understanding that it takes a whole suite of teams in order to take care of things from even writing the proposals all the way to bringing things into market. And I think it's heartwarming and promising that the RDIA is talking about training people, giving certifications on managing research, on commercialization, because at the moment we do not have things such as patent law lawyers in the Saudi Arabia. We do not have, there's something that is called research management certification. We don't have that. And so you get, and this is problematic even internally, because not only do you have to motivate, in my position, not only do I have to motivate the faculty, I have to make the case for the upper management and the external management. So there's a culture aspect, and I think one of the most promising things about these times in Saudi Arabia is that we're in the middle of having a shift or like a change.
Transition, I think.
Yeah,
As Hussam mentioned, and the colleagues, there is a big transition now.
The more we have good events like this, the more we talk about it, the more we get people interested in writing about it and talking about it. And also it's part of the culture to not have extreme expectations. Is that not because Al Faisal managed to streamline its technology transfer policy last year, that this year will have 7 or 8
patent
spin-offs coming out and patents of that. So there's an aspect in research is about risk. It's about making mistakes. It's about a lot of things going wrong. But it's like there was this school of music where someone from the board of trustees came and said that they'll have 300 Mozart coming out. And it's not about having the 300 Mozart coming out, but it's having about the system where if there is an actually Mozart, that we'll actually be able to come out without any difficulty. So that's the cultural aspect. I'm sorry for
Thank you so much. I think Dr. Wafa wants to make a comment. Yes, please.
Something. Thank you.
She will share with us
I think,
in the UK.
I am with you. So I think I would like to add, I think I agree on what's been said, but we are in a transitional situation where the role of the academia and research is evolving and changing. And I think as well as the pure research, there is a great need for the empirical research where we need the community. So we need to include the community, raise their awareness and make them involved. And I'll give few examples. Our hydrogen project and the facility we built, it is for producing green hydrogen to fuel vehicles. Once we do that, unless the public are aware and agreeing and understanding what's going on, they're not going to buy a hydrogen vehicle because it's slower than the petrol vehicle, the very powerful petrol vehicles they used to, especially in Saudi Arabia and these countries. So we need to raise their awareness, get them involved, invite them to the university, show them the facility, making them wanting to contribute to the environment and use these hydrogen vehicles. I have another project on autonomous vehicles. And again, autonomous vehicles will be slower than the very powerful vehicles. We are implementing now a project to get the autonomous vehicles to be used to deliver food from the supermarket to the houses. To raise awareness of the people about the autonomous vehicles and how does it work and what's this technology, why we're using it to improve the environment and support it. Another project I have on the food waste recycling. So we are encouraging the students, it's a project for our students at PNU, industrial and electrical engineering, to manufacture and produce a food waste recycling machine. And we give them a panel, a solar panel from the leftovers of the project to try to power the food waste machine using this CPV panels. So I think this is the component which is missing is the community. And related to that is the decision makers, the government and the government bodies. Like we need to work with the decision makers, the city. The metro system which they are building in Riyadh is going to operate very soon. Unless the public support that and the Saudi public use it, it will deteriorate and it will be a waste of an investment. So you need to bring the public on board. So we do research about the metro and the environmental benefits of the metro and the congestion reduction, but the public as well needs to be included there.
So society engagement.
Absolutely, yes. So I think that is becoming more and more an important component of the research, the empirical research, which, as you said, are evolving in our research definition and approaches. So that is one component needs to be considered. I have one question for you that you talked about for the is that you talked about like you're aligned with the national vision and national regulations about research, and you're also actually aligned with the international regulations. You need to have the citable research and published in certain ways and form. How do you, as like you're all head of research, etc. at universities, how do you achieve that? How do you set incentives, for example, for the individuals and the academic to achieve that? Thank you.
So I think we can conclude with this question, and we need just 1 minute about this issue. We can start with Anis, because about her question. Can you repeat, Dr. Wafa, please?
So I'm saying that you said you're aligned with the national vision and regulations about research.
Yes.
And the international, because in order to have a ranking on the international journals, etc., you need to produce publications which are citable and high quality and Q1 journals, etc. How do you plan for that? I mean, do you implement certain incentives to encourage the academics to publish in these reputable journals or Q1 journals?
We can start with Anis.
So basically here in Princeton University, when we want to establish any new policy, first of all, we need to set what are the objectives that we need to achieve. So some of the objectives are those that are cited in the ranking systems, because they care about quality of publications and these kind of things. And some of the requirements also are discussed with the higher management and also with the researchers. You know, at the end, we want to establish an ecosystem that will make everybody happy, either the higher management or the faculty member. So for publications, we set a strategy in order to increase. So we have boosted the productivity 6 times as from the time where we started. And of course, there is an incentive strategy that is very well tuned. It's not completely open, it's very well tuned in order to increase numbers and quality at the same time. And we care a lot about quality. This is why every year we are actually revising the policies and according to the information that we collect from our databases. We have complete information system that we collect all the different types of publications. We map them to the objective that we want to achieve, and based on this we are going to set new strategies in order to maintain or to improve or the productivity or the KPIs for the next years. So
I think, Anis, you can expect, because in our university, I think Anis can clarify, depending on the journal Q1 or Q2, you get a certain amount, the number of authors. Maybe you can clarify, because she wants more details.
So of course we care about the number of authors, of whether it is collaboration, whether it is pure research lab. For example, recently we wanted to promote more the research that is produced by Princeton University because we think about innovation. And of course collaboration is also important. But when you talk about innovation, you want to have something that you build it on your own, not that you export it from outside. This is part of the strategy that we are currently setting now. For example, Times Higher Education have released a new type of KPIs, a new type of metrics, and we are now trying to accommodate our bylaws to cope with the new ranking system that is proposed by Times Higher Education. So it is a completely dynamic system that is based on feedback, that is based on different type of inputs, either from our faculty members, for example, and the College of Humanity and Science. I would like to acknowledge them. They are one of the most active colleges that brought us feedback from their faculty members, that we discuss them, we try to how to accommodate this. As I told from the beginning, our objective also is to meet the KPIs, but our mission is to make everyone here happy, both the higher management and the faculty.
Let's move to Dr. Abdullah. We can learn a lot from KPPM.
From KPPM, we do things slightly different. The Research Management Office has monitor every single publication, since you are talking about publication. In fact, as an institution, if the journal is not ISI or Web of Science Index, we don't even count Scopus. there is an overlap, but mainly we are looking at that doesn't count in the evaluation, doesn't count in promotion, doesn't count anywhere. We monitor we monitor affiliation. If anybody within it goes to ethics committee directly, if there is a double affiliation or affiliating. So this is the role of the project management office. Number one, we don't believe in incentive. I think that's driving misbehavior in general, and behavior goes so we don't have incentive whatsoever. We put it part of the expectation of the faculty in their annual performance. They need to, and since I'm mentioning Web of Science, we excluded journals that are associated with low reputation publisher like Hindawi and MDBI. We don't encourage our faculty, and we don't support it, because these publishers in particular, though it's indexed, but those publishers globally, there is issues with how paper get reviewed, and it's mainly about you pay the money, they give you a superficial review, and the paper get accepted in no time. And so there is a rigor research management office monitor. So it's not a loose end. And
in KPFM, how much? How many papers?
We expect faculty to contribute, depends on the funding. So it's not beer. It's depend if you have a graduate student or you don't have a graduate student. You have a fund or you don't have a fund. If you are a new faculty member, how would I expect from you 2-3 journal publication in the first year or 2 years? So no, you don't need to have. So these one size fit all. I think these among the behavior academic institution, they need to adapt themselves even internally. There is no one size fit. The College of Humanity is totally different from the College of Science. And the number of venue for publication. The business school is even the extreme. The lead time in certain journal in business related, it takes 1.5 years or 2 years. I cannot compare. So one size fit all, and this is the average number. And we have faculty who are well rich, and they are publishing 40 per year because they have 15, 20 graduate students and 4 or 5 postdocs, and they have 4 million, 5 million real research funding. I cannot compare this faculty with a faculty who he or she. So this is the role of a research management office to monitor, to assure regulation, and thank you.
Thank you. Let's move to Dr. Abdul Hamid. Yes, please. KPFM, yeah. Just 2 minutes, we will finish. Yes, please.
Sure. I think to answer the question about alignment with the global interests, I think there are 2 aspects of this. One is that we have to really appreciate that the looking inwards and addressing local challenges and local problems merits being global in their interest. Because the things that we're facing over here are similar to the things that are being faced in many other places. And so if we manage to address this is good. The other thing is that one thing that we have to do is continuous engagement. One of the things that we did in our city hall meetings and setting the themes is that we would ask is that if this is relevant locally and if this is relevant globally. And these are the people who go to conferences, these are the people who go and visit other universities in the summer, and these are the people who are getting their research published. And so this gives us an idea about that we're not completely isolated from where things are going. So this is just to answer that aspect.
Okay, just 1 minute, last minute, because we are running on time. Hussam, please.
I think
because Cox also has another experience, I guess.
Yeah. So I think the incentives that are made are linked to their track they can start as an assistant professor to associate professor to professor with a certain scoring systems, certain quality of papers that are required from them. As Dr. Abdullah mentioned, every case is by case. Every field has its own consideration, its own publication, its own outcome that is expected from it. It's definitely a case by case. But we're not against, of course, publication. Publications are very important. I just want to reiterate. I have done publications. Publications are very important. They are KPIs, but how can we translate that KPI to an objective key result, OKR? How can we make that KPI of that number of research to the OKR of making an impact, and whatever impact, whether it's social, whether it's economical, whether it's environmental, it's whatever impact that may be.
Thank you so much. So now let's applaud our invited speaker. And now I will call our dean to distribute the trophies for our guests. Thank you so much. It was very, very insightful discussion. Thank you so much.